we'll get started. Ozan, you ready?
Yes.
All right.
All right. Well, I want to say welcome to everybody that joined us today. We've got a really exciting set of knowledge that we want to share between Mission and AWS teams. I just wanted to say thank you for making time for us. Let's roll to the next slide, please. A little bit about myself. My name is Ozan Telu, and I'm with AWS. I'm a solution architect leader here. I've got 1 year under my belt here at AWS, but before that, I had 22 years of IT career. I led product teams and led service delivery teams, had IT leadership roles, reporting to mid-market firms, CIOs. And you know what I'm most excited about is I lead a team at AWS that help customers begin their journey with AWS and architect their solutions to help them scale and transform their businesses. And we deal with all kinds of different customer scenarios, and we also work with great partners like Mission, and it's really fun to be speaking to you today and share our knowledge. I want to turn over to Scott. Let's move on to the next slide, please.
My name is Scott Goldberg. I'm manager of the Solutions Architects team here at Mission. I've been working in technology for a number of years now, primarily in the public cloud space. I spent some time working in the Akamai NOC, right? So doing like edge computing, and then also as an IT auditor with Fidelity, which is definitely an interesting job. I've held several positions at Mission over the last 7 years, worked my way through engineering roles on our DevOps team, and then more recently on the solutions architect side. So personally, I'm a major smart home enthusiast, and I'm into 3D printing. So if anybody needs some tech tips or wants to nerd out on that stuff, you can always feel free to let me know. We've got a pack of solutions architects here that are going to be running through the labs today. I will start with Brian. He can introduce himself.
Hey everybody, my name is Brian Riesgraff, Solutions Architect here with Mission. I'm actually a former AWS Solutions Architect. My cloud journey is fairly new in the last several years. My IT career goes back to working in education as an IT tech when I was like 19. I've been doing it ever since. And I'm happy to be here and to walk you guys through some content. Kick it over to Lance.
Hello, good morning or good afternoon, depending on where you are. My name is Lance. I am with Mission. I'm on the Solutions Architect team. So I've been in the IT industry for about 8 years or so now. Been in operational and engineering roles my whole time. So came up in IT as a help desk IT guy, eventually became more of a sysadmin, managing the actual tech infrastructure, started working in the cloud and deploying workloads on AWS, doing operations and monitoring, moved more into consulting, was on a platform team building internal tools, and now in my career, I'm really more on the sales side. So I help our sales team here at Mission talk with customers, understand their businesses and some of the business challenges, and help translate a lot of the technology into solutions for our customers. Over to Mohit.
Thank you, Lance. Good morning, everybody. My name is Mohit. So I am a solution architect at AWS. I've been here since December 2020, but I've been using AWS professionally as a cloud engineer since 2015. So on a nutshell, I can say my job is to be like a Sherpa, help customers navigate the cloud. Been in IT for more than 10 years now. Started my journey as a software QA engineer and moved on to sysadmins, DevOps, cloud, and now as a solutions architect. Very happy to be here and help you walk through some content in security that is extremely important in today's world. So thank you, and over to you, Cheng.
Hey, thanks, Mohit. Hi, everyone. My name is Chen Lun, and I am a solution architect with AWS. I've been with AWS for about 7-8 months now. Before I joined AWS, I was a senior manager for the site reliability engineer team, And over the last few years, I've been helping multiple companies, retail or healthcare, modernize their application and move to the cloud. And happy to be here to share the knowledge of AWS with all you guys and hope you have a fun day with us. And back to you, Jose or Scott.
Well, good. So I wanted to kind of walk through at a high level what our agenda is going to look like, what our team is going to cover with you. We've got some foundational building blocks about AWS that we're going to walk through. First, we're just going through the introductions right now, but after that, we're going to get into the core compute. We're going to talk about EC2. Then we're going to move on to storage layer. We're going to talk about S3, and then we're going to move on to security, like Mohit mentioned. Let's move on to the next slide. We'll have a break here at 10:35 to 10:45. So if you're looking forward to that, let's take that time. And then we're going to cover networking, which is going to kind of bring all these things together in the context of our virtual private cloud lab. That's going to help wire these solutions in the core components. So, and then we'll have conclusive steps, and then we'll call it a day at 12:45. So that's our agenda based on Pacific time. So, Scott?
Great, thank you. So I know everyone here, I'm sure, knows all about AWS, but I wanted to spend a couple minutes kind of just giving a quick background of who Mission is, what we do. So we're a premier consulting partner for AWS Web Services solely, and also a managed services provider. So we offer a range of services that are focused 100% on AWS. So what is it that we do exactly? We like to describe it across the 4 phases that you see here of the cloud journey: architect, migrate, manage, and optimize. And so we can help you with everything from planning out a migration to AWS, including roadmaps, proofs of concepts, AWS best practices, everything that you might need in the planning stages anyway, all the way through to ongoing management of your environment once you're running in the cloud. Including things like DevOps consultation, AI/ML work, account management, 24/7 monitoring and support. And finally, once you're running smoothly in the cloud, it's then all about continuously improving and optimizing for cost and performance. So Mission's really here to help you across all of these areas, and we definitely have the credentials to show that we are successful at them. So we're vetted and validated by AWS. That's how we got this Premier Consulting Partner designation, which is the highest tier partner you can be. And it really takes a lot of effort to get it. So we're super excited to have achieved that. We also have a number of competencies which AWS provides in specific areas, which further speak to our breadth of experience anyway. So they've looked at our case studies, our methodologies, and they validated that we know what we're doing in the areas that you see below. Most notably for migrations, DevOps, Microsoft workloads, but there are also some other competencies we have in specific verticals like SaaS, healthcare, and life sciences. So we're SOC 2 and ISO 27001 audited, and that's pretty much it. If you guys, anyone else has any questions as we're going throughout the day, you can feel free to pop them in the chat over on the side of the GoToMeeting panel.
Excellent. So I just wanted to touch on our partnerships here on AWS because Mission clearly being a premier partner kind of speaks volumes in our eyes. We actually vet our partners very closely on an ongoing basis, and frankly, we look for feedback from our customers as we vet them. Which your voice is important to both Mission and AWS as you go through the journey. But why partners? What does that mean and bring to table? I just want to touch on that. There are over 1 million active customers on AWS platform at any point in time. And what that brings is really an interest for global partners, a network that AWS is able to assemble to support the needs of those active 1 million plus customers. So this is a true network effect. The more customers use AWS, the more partners that we're able to bring to table and create that market where we can bring technology partners, find the customers, and vice versa. And we bring 2 types of partners. One of them is these consulting partners, which Mission is on the highest tier. And then the other one is the ISV partners, which is the software solutions that you care to use on premise are available on top of AWS. And that's what you will find as the second concept we have, which is the APN technology partners that you see on the right. So why partners? Let's move on to the next slide and touch on this. What we find over and over again is while AWS architects help our customers as a part of that engagement model, it becomes obvious that that migration or building out new applications require A, additional muscle, B, deeper knowledge in the technology domains that we're architecting these solutions for. And typically our customers either have extremely busy resources that aren't ready to take on the new project, or there's some skill gap that needs to be circumvented in the near term as the project build out occurs in a fast pace to meet the needs of the business. This is where the best practice is needed, and that's what Mission brings to the table. And this then reduces the time to value, and it creates the technology solutions and meeting the roadmap asks that the businesses have from our customers, IT departments. So hopefully you can see the value that Mission and AWS brings to this table as maybe a microcosm of what you can expect in your engagements with AWS as we build and architect new solutions for you. With that, I wanted to kind of turn over back to Scott on the next content here.
It's a perfect segue, right? I think like our partnership and the partner network in general kind of gives birth to a lot of great programs and funding opportunities, right? You know, they're kind of jointly ran by AWS and partners like Mission. And so this one in particular, this invitation-only Enterprise Activate program, is really designed to help companies like yours get some foundational knowledge of AWS. So as part of this, you'll have obviously today's content, but also access to AWS professional services essays, as well as on the Mission side, various training and certification programs, and also an opportunity for an assessment of your environment against AWS best practices. And so make sure you stay to the end to take advantage of this special offer. I think we're ready to roll into the first lab. So I'm gonna pass it over to Lance. We'll give him a second to get set up. I think Ozan will stop sharing, or whoever's sharing will stop, and we'll turn it over to Lance.
Perfect.
Excellent. All righty, let's do this thing. So again, good morning, good afternoon. My name is Lance. I'm going to be walking you through the first couple of content slides and labs. So the first thing we're going to go over is just a kind of a AWS 101. We're going to talk about the business itself, how it came about, kind of what sets it apart compared to the other cloud providers, and the things that make AWS great. So we're going to run through this, and then we're going to go right into kind of the flagship product, which is compute, and your ability to spin up machines and hardware, virtual systems on AWS on the fly. Part of the reason this whole cloud thing is so powerful and becoming so popular. So at this point in time, AWS is a massive outfit. It's globally spanning. There's presence in every major continent. There's just infrastructure in place across the world, and you have a huge set of infrastructure that customers are able to tap into. And because of the way that AWS has been building out their platform and their services, it has become very low cost. It's flexible and easy to use. It's incredibly secure. Security is kind of the number one objective on AWS. It's elastic. Your machines and your services can auto scale and resize on the fly, and you can scale out and in incredibly quickly, and you're able to run workloads pretty much anywhere. So if you're trying to target users in a certain region, you have all kinds of tools at your disposal to be able to get content to them faster or get them to your system faster. So we're going to talk a little bit more about all that. Right. So some of the things that sets it apart. So they've been building their cloud platform since about 2006. Now at the time it was fairly rudimentary. There was just a couple of services that were in place. I think they launched with DynamoDB, somewhat of a NoSQL database system, but they've been iterating on the product ever since. Today there are over 175 services in the catalog. So when we log into the console here in a bit, and I'm walking you through the lab, you'll see all the services, and your mind's gonna melt a little bit. It's crazy how much stuff they've got, and what's crazier is how much more they keep pumping out. It's hard for us to even keep these slides up to date. I feel like every time I give one of these immersion days, my slides are out of date. All of a sudden, there's even more AWS services, there's more regions, there's more availability zones, there's more edge locations. So we got to keep bumping up the numbers. I think we got smart a little bit here, where we just said, you know what, it's 175 plus. So then we don't have to update the slides as much. But the point is there's a lot, and it's constantly growing. We maintain some RSS feeds to get notified when AWS is launching new services or features or functionality. And the thing is full. Every single day there's at least 5 to 10 updates of new services and features in existing services. So the pace of innovation is crazy. It's unmatched when looking at the other clouds. AWS is constantly iterating on the product and always making it better. So I covered the numbers on the global footprint here, but just to kind of reiterate, and I'm going to talk more specifically about these terms because they're AWS specific, but 24 regions around the world. Availability zones are sub-components of a region, and edge location is more for like CloudFront, the CDN component, right? There's edge location, so when users are retrieving content from a CDN, the edge locations are more geographically closer to the user, so they're able to download the content much faster. The way that AWS does their pricing, we like to say that they offer a lot of knobs and levers. You have all kinds of different pricing options for all the different services. And just different ways to break down the costs and different ways for customers to choose the right blend of performance, efficiency, and cost. And on top of all those things, the ecosystem is massive. So if you're wanting to spin up some custom software, or launch some specific operating system, there's a whole marketplace full of vendors and partners and integrators of the AWS platform who have their products up there. So whether that's some like niche security thing, like you want to run like Snort Suite and Wazoo server, like a lot of the offerings out there you can find in the ecosystem and be able to spin up services and just leverage on demand. So 90% of the AWS roadmap comes from customers of AWS hitting an edge case and needing some sort of change implemented in order to work around it. So this little testimony, like a little user testimonial thing, is from Heroku. So for those that don't know, Heroku is a platform as a service, software as a service type of offering, but it basically allows developers to package and deploy their code into this cloud very low friction. It has capabilities of like a low code, no code kind of system in which if I had an application that I was developing, I could just upload it to Heroku and Heroku's service would run my application on their infrastructure. They are users of AWS. So under the hood, when you're using Heroku, you're actually running on AWS's infrastructure, just abstracted through their platform. And they at the time, Heroku was needing all kinds of compute to run these workloads. Even for the user, it was a low code, no code thing. There was still a server behind the scenes running these applications. And so at this time, Heroku was working with the T2 series compute instances, which I'll talk about more here in a minute. And they just needed more flexible options in terms of like the performance and they don't. The T2 series was too locked or too fixed for it to be flexible for them. And so in working with AWS, they were able to work with the team to get a new T3 series rolled out, which has all kinds of different knobs and levers for the pricing and the performance options. There's different burst capabilities that you can enable or disable on the fly. And just more ways to be flexible with your compute, the infrastructure, and the cost. So when customers have problems, AWS listens and they turn around and implement a lot of the pain point things and help address those for their customers. Customer obsessed is a term you'll hear a lot if you ever talk with partners or like your AWS account team. We all kind of pride ourselves on being customer obsessed. We want what's in the best interest of your business, and we want to just see everybody thrive, essentially. So this little map view is a depiction of the regions that are available on AWS. And so a region is somewhat of a, I'll go to the next slide and I'll show you there. So when we say region, this is basically what we're alluding to. So in AWS, there is a region, which is just a kind of general global location. And then within the region, there's subcomponents that AWS calls availability zones, or AZ. And so an availability zone is basically just a data center. And each region on AWS has multiple AZs, multiple data centers, all tied in this hub and spoke manner. So when I go back to this world map and we're looking at the regions here, and each of these regions is comprised of several other data centers, typically 3 or more. And so what this allows customers to do is build highly resilient, highly durable workloads that can span different data centers and even different regions, all along the same backbone. So for customers with more complex needs, who are operating more at scale, they have the ability to launch on various different data centers of these availability zones and regions, and have a very widespread deployment. And with the other AWS services, that whole process becomes even easier, right? When we're talking about having database engines that can replicate their data to other regions. You can maintain presence a lot more easily with the AWS tools and services. So this is more the view of the edge location. So you'll see some of the hubs on the various continents, and you'll see the little blue and green dots spread throughout. So these are places where AWS has infrastructure. You don't necessarily you won't be able to run workloads in all of these because these are more for the edge and delivering content to users around the world. And of course, all of these components are linked together in some way. So when you're working on AWS, you might have a workload that's limited to a specific region, but you have the ability to connect, any of your workloads and any of the networks or the VPCs that you create. You can plug any of those into each other and build up a large kind of network mesh and be able to route and connect to all of your various workloads. Excuse me one second. Alrighty, back. All right, so that's kind of AWS 101. We like to give this intro, just kind of give some background about the platform and show some of the capabilities that sets it apart from the other clouds. So in this same slide, I'm just going to keep going here, but we're moving on to the next topic, which is really discussing more of the compute options that customers have on AWS. So the most obvious one, or the most straightforward, is essentially VPS, virtual private server. Be able to spin up virtual machines or servers in the cloud on the fly. This is kind of one of the more flagship products, Elastic Cloud Compute, EC2, in which customers can use the API or the web console and provision virtual machines. We're going to go through a bit of this during our lab here in a bit, but essentially, outfitted with a key, customers who spin up EC2 instances get administrative access to that machine, and they can SSH or RDP. They can connect to the machine and manage it like it's one of their own. The only difference is you just can't walk over to it and touch it. You've got to access these systems remotely since they are in the cloud. So in addition to that, there's other compute services that are not exactly the same, right? So specifically these other two that you see here. So AWS Lambda, Amazon ECS, EKS, and Fargate. So the first one I'll talk about is ECS, EKS, and Fargate. So this is the container management services that Amazon offers. So for customers familiar with Kubernetes, EKS is AWS's offering a managed service Kubernetes service. ECS is AWS's very own container orchestration service. So an equivalent, comparable service to Kubernetes, different feature sets, different capabilities. And Fargate is called out. Fargate is really more of a mode in which you can run ECS. So typically when running this type of workload, customers will run their own EC2 instances. And normally through something called auto-scaling groups, in which you can just define, I want to have a group of instances. At minimum there should be 5, and at maximum there should be 15, for example. And that auto-scaling group will add and remove servers depending on the thresholds that you give it for scaling. And so this is the backbone for most compute workloads, an auto-scaling group of EC2. But this Fargate thing you see mentioned here is a service that lets you run containers without any of your own compute. So this is kind of a almost entirely platform as a service, in which you say, I have a Docker container, here it is, here's the registry that it sits in. You give AWS some details, some meta, like configurations. This container should have 1 vCPU and 2 gigs of memory. And these are the secrets that the application needs to know about, the environment variables. And AWS will just run your container in the background for you. Otherwise, the other modes are you host your own EC2 and you have it integrate with your ECS service or your EKS service. So that's for customers who have containerized their applications or their workloads. They're using tools like Docker to package up applications and build Docker images in which they can move images around to different registries and pull new container images in. And that's kind of like what their release process looks like. The other thing mentioned here is Lambda. So Lambda is similar to Fargate, and really it's more of a PaaS thing. Customers are able to upload their code to AWS Lambda. Typically, not everything will just be an outright upload. You typically have to write your functions to integrate into the Lambda service. But it gives customers a way to run applications, run their workloads without a server that they have to then manage and maintain. So this is basically a serverless technology, in serverless to the customer. There's still a server behind the scenes. You just don't have to do any management of that server. You basically just say, here's the runtime I want. I've got a Python application. It's version 3.8. And you have Python code and a Lambda function, which can be invoked from an API gateway that's out on the edge, or even like an application load balancer can route requests to an AWS Lambda function, which as a request is received, the Lambda gets invoked, and any logic in the function gets played out, and responses get returned back to the user. And that could be a RESTful API JSON payload response, or it could be like HTML rendering content in a browser. So lots of options. There's even more than this. These are just kind of the main products that customers are using. So I'm going to talk about each of these in order for a few minutes. Again, EC2 is kind of the flagship compute server as a service thing. So customers use EC2 to be able to spin up workloads in any sort of operating system flavor. The most common ones are Linux and Windows, but of course there are offshoots. There's more Unixy systems. If you're into FreeBSD and OpenBSD, you'll find images of those things available. There's a lot of ARM-based processors coming out, and operating systems geared towards those architectures. For any sort of customer need, there's different blends, right? Customers are able to use different compute tiers to suit their type of workload. I'll get more into that in a minute. But basically, it gives customers the flexibility to pick and choose which compute components are right for them, and then mix and match all these things to get the right blend. Sometimes customers do have a need for actual bare metal, and they don't want to be running on a virtual server, or they don't want that shared tenancy, and they want more dedicated. You can run your own bare metal on AWS, and that'll still include the other capabilities like the elastic networking and the elastic block storage for storage. A lot of these capabilities are just AWS native. They come out of the box. A lot of the options that you have available to you are just all kind of built in AWS, but you do have community options as well. Primarily around the images, and when you're launching a server, which operating system you're picking and choosing from. There's a ton of these community AMIs, and when we're going through the lab, I'll show you. We'll poke around in the community AMIs, and we can see how many are out there. And there's different ways to pay. The default and most widely used is on demand. So that's your average AWS user who goes into the AWS console and launches an EC2 instance. The pricing is going to be on demand. And for customers who have been on AWS for a little while, they're more advanced, they're more familiar with the internals. They can use something called reserved instances to basically reserve a stake of that compute and lock in pricing. And usually there's an upfront payment, which gets you a discount, especially at scale. That's very useful for customers with a lot of compute needs. And the last thing mentioned there is Spot. So Spot instances are awesome, and I don't think are used enough, but it's basically a marketplace within AWS where customers can buy and sell Spot instances of compute. And this is basically low or limited capacity stuff in which if I'm running a workload and I need to run some background job processor, it doesn't matter too much if the job processor goes away or dies, because it can always just be resumed again from the exact same spot without much fuss. So Spot is for those types of workloads. It's a fraction of the price you typically pay, and it'll when done right, it can save customers a lot of money utilizing this system. The caveat is that you've got to architect your system around it, because at a moment's notice, you could get a 2-minute warning that says your spot bid is now out of the market criteria, and you could lose your compute capacity. And within 2 minutes, your system has to be nimble enough to fail over to on-demand instances if you need that workload running. But we see customers do a lot of cool things to blend both spot, reserved instance, and on-demand, making use of auto-scaling groups, like I mentioned, in which they can run a whole fleet of servers as spot instances, for 70% of the workload. And in the event that there's that marketplace shift and their bid is too low, and they're going to lose those spot instances, their system will just automatically adapt. The on-demand instances will scale up, the spot instances will scale down. For a few minutes, they'll be primarily on-demand instances, and then some automated system will redo the spot bid and get their spot compute back at low cost, and then just change the auto scaling group. So toggle them, basically have the on-demand scale down, have the spot scale up. So a lot of different ways to blend these things together. So it's very powerful stuff. So we had already touched on regions and availability zones and some of the terminology here. And then, to fit into that, I just want to talk about the terminology on the EC2 side. Right, so when launching an EC2 instance, or just even working with them, there's this concept of an Amazon machine image, or an AMI. Some people call them AMIs. I don't think you should. You say AMI. But the AMI is like the core image of the system. It is basically a snapshot in time of the operating system and all the contents of the file system. And when you're making an image, you basically are capturing, the contents of this server, and you can launch new servers from that state in time. So this is the premise for the whole auto scaling group thing I keep talking about. In your auto scaling group, you define an AMI that you want to use for your group, and you set some parameters around it. I want to run minimum 5, maximum 15, and give me just 10 for right now. You'll see all these instances come online utilizing the same AMI, machine image. So this is, typically the mechanism that we're seeing for, web servers or application servers, or stateless applications running on ephemeral servers, which are spinning up and down on the fly. And so now this fits back into that whole region and AZ construct. So when customers are running workloads on AWS, it's all predicated on some sort of networking, which AWS calls virtual private cloud, or VPC. And that VPC will exist in a region. And within that VPC, it can span multiple subnets. And those subnets will reside in an availability zone. So earlier when I was talking about the regional presence and your ability to span different data centers and regions, this is part of that component. So back to the auto scaling group thing, if I had an auto scaling, that same exact one, the 5, 10, and 15, I can set my auto-scaling group to span multiple availability zones. So as new servers are coming online, they're basically being load balanced into availability zones. In this depiction, it's A and B. Typically, we like to do A, B, and C. And so as all my servers are coming online, I like for them to be dispersed across those availability zones. So if there's ever a problem in AZA, I know my workload's safe because I've got plenty of compute capacity in AZB and AZC. There's a couple more components in this slide with regards to EBS, but we're gonna cover that more in depth. So I'm just gonna move on. All right, so these are some of the options in terms of processors for compute workloads that customers can choose from. So this, a lot of these are familiar. You'll recognize, most customers recognize all these right away. These are kind of the big players in the space, right? Intel, NVIDIA, AMD, and then AWS has also kind of rolled out their own processor architectures, right? With the Graviton, the ARM-based processor, and a newer one called Inferentia. But the point here is that there's a lot of options to choose from. And now, earlier I was referencing like different compute types and the options and different ways for customers to pick and choose to best meet their workloads criteria. This is what I was referring to. So you'll notice this, it's really more of a spectrum in terms of capabilities and features. And it comes down to what you plan to run on these machines. So if I've got a Java-based application, I want to run it on EC2, and I'm evaluating which instance type is right for me. Like what's the series that I should probably evaluate and pick. For a Java app, Java tends to be very memory hungry and basically just require lots of memory of the server that it's running on. So I might do a memory intensive or a memory optimized instance like an R5. Same thing goes for databases. SQL servers notorious for eating up. Well, it does it on purpose, but it holds all of the available system memory basically in cache, and it utilizes memory heavily to read and write data to the system. So like a SQL server deployment, you might use a memory optimized instance. If I'm doing more things like rendering and making use of a GPU, I would probably use more of a graphics intensive or even a general purpose GPU. If I was doing something more compute intensive and I just needed kind of raw speed and performance on my underlying processor, I would do more of the compute intensive, like C5, right? So the point here is that no matter what your workload is or the characteristics of that workload and how it's utilizing system resources, you can pick and choose instance types to meet the specification, and customers are encouraged to try them out because of the nature of this all being on demand and on the fly. You can provision your entire workload with a mixture of series. You can load test it, and then you can tear it down and retain your metrics of the load test and go through this series to find the actual, the right blend of instance types and configurations and whatnot. So all the nice thing about all this stuff is that it's all malleable. If you're launching compute instances and you're doing a C5 today, but down the line you want to switch to an M5, you'll find that it's very easy to just switch those things around. And if you're architecting your system in such a way that all of the configurations have been codified in some way, they can be recreated, you'll find that your system will be even more nimble and you can switch around these things even faster. So aside from the types and the different ways you can pick compute options, you can also pick different sizes. So a lot of customers are used to this type of scale up model where if I'm running a workload, I would have traditionally have large machines and I would scale them up as needed when I had some kind of performance need for it. So you'll see the 8x large depicted on the left there. Right, so that's going to be a big beefy machine with lots of system resources available for that thing to do whatever it's got to do. But the sizing options, as you can see, it's basically breaking down in half, and that it directly correlates with the price, right? So a 4x large of any series is exactly half of the 8x large of that same series. And this goes all the way down to X large, and in a lot of cases, there's even lower. Some of the series will have a large, and I think T series is the only ones that will have medium, micro, or medium, small, and micro. But yeah, in addition to the types and the characteristics that you can choose from, you can pick the sizing around all that as well. And this also can be changed on the fly, right? That's a callback to the whole elastic thing. Like this, all of these things are malleable and can be changed on the fly. This is basically the convention. When you see EC2 instances and the instance types and the sizes, this is the syntax of the full thing that you may see. So you basically just combine the instance family with the generation of it. So as they iterate, right, maybe next year we'll see a C6 something. And then sometimes there's this extra attribute. Some of the core instance types will, like C5 is just that, it's a C5. But now there's additional attributes that you can get, like a C5N. I don't remember what this one is. I want to say it's like enhanced networking or something like that. But it's an additional attribute for that sort of that compute option, and then followed by the size. Right, so you'll see this when you're navigating the console, you're spinning up instances and working with them. This is the syntax you'll see. So in terms of the operating systems, now kind of looking at what's actually running on this compute, there's a ton. All the major operating systems are supported. Most of the offshoots or various flavors of Linux are available. Some of the most common ones that businesses are running are like CentOS and Red Hat Linux. Ubuntu is really popular, especially the developer crowd. It's really common OS. Debian for old school Linux admins. Amazon even has their own Linux distribution. I believe it's CentOS based because it uses the Yum package manager, but that's a really popular option for deploying workloads is Amazon Linux. It's basically CentOS, which has been tuned specifically by AWS for AWS. So a lot of the services that have built-in, like they're made for the service, are using Amazon Linux under the hood. And then of course all the versions of Windows Server are available. And as of last reInvent, there's Mac. You can now run some Mac operating systems on AWS, which is really useful for software developers or teams, anybody who's running something that they expect to run on OS X or Mac OS. You can spin those machines up now and test your stuff out a lot faster. Let's see. All right, I'm gonna start switching gears over to our lab. I've got several more slides, but I won't have time for all of them. We talked about the purchasing options. We talked about the virtualization aspect and how EC2 at its core is virtual machines. You can get bare metal if you need to. There's just a lot on the platform, right? There's whatever vendor you're working with, if you want to maintain those systems, there's very likely cloud capabilities. There's going to be a cloud version of the software or the system that you're using, right? Not only is there a really big partner network, of which Mission is a part of, being a consulting partner. There's other businesses like us that do consulting and integrations, but maybe on different parts of the business. There's also this AWS marketplace for more of the actual software needs, to be able to spin up different software solutions, most of them turnkey. Click a button and now it's running in your environment. Alrighty.
Hey Lance, we do have a question from Raymond. He's asking, what do you use for backups?
Great question. So AWS has a service that they call AWS Backup. So it's pretty powerful and flexible. We tend to use it exclusively for backups. A lot of the AWS services you'll find will have their own backup component or settings to the service, which is fine. You can take advantage of just the built-in capabilities. For example, if you're running a database on the relational database service, you'll have the ability to just check a box and define some details about backups or snapshots. But we like to use the AWS backup service because it's really more of a policy defined thing in which you can say, look for all of my deployed assets, and if any of them have this tag, snapshot them at this time and send a copy of the snapshot to another region. So rather than me going and defining on each of my deployed assets and saying, you need to back yourself up at this time, you need to back yourself up at this time, I can use AWS Backup to just define a policy that says anything with this tag gets this backup procedure. And you can do it for several different components. And so rather than maintaining these bespoke backup settings and configurations, you can use AWS Backup to tie that all together. Unfortunately, I can't hear anybody. I can't hear any of the attendees, but I hope I answered your question. And if you have any kind of follow-ups to it, feel free to throw it in the chat as well. Are there any other questions out there before I move on to our EC2 lab? Alrighty, moving on. Okay, so that was the intro to AWS and compute options on AWS. I'm going to go into a lab where we're going to talk more about EC2. I'm going to basically walk you through a deployment of a simple EC2 instance. We're going to use some of the features that we were just discussing on that last slide, and then I'm going to show you some of the cool stuff that you can do on the platform. And there's going to be a couple options here. So let me pull up my lab document and then we will get started. All right, sorry, it took me a second to find my lab document. So everyone should have received some links or credentials to something called Event Engine. So that is Amazon's lab account vending machine system. So basically, it gives us all an AWS account to go through this lab document with, and we're going to have this little sandbox to play around essentially. So if you're watching the screen, I've got the lab pulled up on the left, and I've got the AWS console pulled up on the right. I've logged into that event engine panel, and I'm in my AWS account, and I skipped a step, but I'm in the EC2 console, right? So if you don't know how to get here, at the very top of your AWS console, you can just type EC2 and click the first response there, and you'll end up in the EC2 console, like how I am, and you'll see kind of an overview. So I'm going to walk through this lab document initially. So you are all welcome to do the lab on your own. You can follow me on the share. You can look at the lab content for yourself. I believe it's been shared in the handout section. EC2 Linux hands-on lab. But basically, we're going to go through the motion of launching an EC2 instance, setting some parameters and data around it, and we're going to deploy a simple web server and PHP site to this instance. And we're going to connect to it. We're going to do some stuff in the shell. I'm going to go off script a little bit and have a little bit of fun, because that's what I like to do. And we're going to have a good time and learn some cool stuff. Ready? Let's go. So the first thing that we do, right, before we launch any compute, we need an SSH key pair. So now, if you're used to managing Linux systems, that should sound familiar to you. SSH is kind of the de facto way that we manage and maintain Linux servers. But if you're used to managing Windows servers, you might say, well, what am I going to do with this SSH key? If you got a Windows server, you actually use that SSH key to decrypt the password to your Windows server. So through the console, you decrypt the password by uploading the SSH key that you've provisioned and downloaded. The password gets decrypted and shown to you in the console. You copy it, you put it in a password manager, or you put it directly in an RDP session, and now you've got an RDP session on that Windows server. So I don't know about you all, but when I did the event engine setup, it gave me an SSH key already. I'm going to disregard that for now, and I'm just going to make my own just so you can see it. So in this AWS, I'm going to expand it so we're full screen here. In this console, there's a lot of stuff going on. But we're basically looking at all of these drop downs on the left. And since we're wanting to provision a new SSH key, that happens in the network and security section under key pairs. So I'm going to go into the key pairs. There's the one that I got for the event. I'm going to make a new one for good measure, and I'm going to call it Lance Immersion Day ID. If you're on a Windows machine, you might want to download the PPK so you can use that with PuTTY, or if you've got tools in your set already, I always download the PEM file. So when you make this key pair, AWS under the hood is generating that for you. We can see kind of a newly generated fingerprint there, newly generated ID there, and my browser downloaded this key, lance-id.pem. I will leave that there, and I'll come back to that. So we've got our key pair created. Before we launch any compute instances, we need a key pair to be able to access it. And part of when we're doing the launching, it's going to ask us for the key pairs, which is why we have to do this first. Now we're going to launch an actual instance. And let me just read ahead real quick. So we're going to launch an EC2 instance. We're going to use the latest Amazon Linux distribution, Amazon Linux 2. It's going to be a T2 micro. I might change that. And we're going to use something called user data, which is one of my favorite things about AWS. So let me jump back over here. I'm going to go into the instances section on this dropdown, and you can see I don't have anything here. Nothing's been done yet. So I'm going to go to the top right and launch instances. So this kind of goes to what I was saying earlier around the machine images and how you have all these operating systems available to choose from. So we see Mac OS, Big Sur 11.4, Red Hat Enterprise Linux 8, SUSE Linux Enterprise Server, Ubuntu, Windows, different AMIs. This one's got deep learning, MXNet, TensorFlow, PyTorch. These are all like neural networks and things we'll see in machine learning workloads. If you're using tools like these things, you can just launch an AMI that's got them all baked in already. And then you just download your application code and maybe do some additional dependency installation. But you know, the options are here, you know, based depending on your workload. And you'll see in these little other drop downs, a lot of these, you know, the ones that we see on this first page, these are Amazon, these are AWS official AMIs. But you can also go into this whole ecosystem of the marketplace. Anybody can publish their own machine image. Now, of course, there are security implications with this. You don't want to just download any machine image and just hope that the person didn't include anything malicious. There is a very rigorous process to get these servers vetted and validated before they go up here for public consumption. So AWS is looking out for you, but as a general precaution, you want to be mindful about, you know, what you're throwing into production environments essentially. Stick with the core ones and test the community ones as needed. And typically you want to make your own. You know, after you've confirmed it, make your own image from it and use your image to launch. But the options are there. I like FreeBSD because it's fast and jails and FreeBSD are cool. That's an option for me. But for the sake of this demo, I'm going to proceed with an Amazon Linux 2 instance. The lab says T2 micro. That's the default. I'll just leave it. I'm going to go next. And now we got some instance details. There's a lot of stuff here if you're not used to it. Here you can choose which network or VPC you deploy this stuff into, which subnet it goes into. If you want the instance to have a public IP, if you want it to be a spot instance, you can do that in here. And you'll see back to the whole spot instance with the bids and stuff. This is one way that you could do that. You can, you know, it will show you the current price of the spot instance, and you can put in your bid or what you want to pay for it. I'm going to real quickly EC2 T2 pricing. Sorry, I'm going off script real quick, but I just wanted to show, you know, I had mentioned the price point of spot instances previously, and I just wanted to showcase that. So a T2 micro, which you're using, is typically on-demand price is 0.0116. So in about a month, that's going to be about $8, which is not much, but if we're looking at different workloads and compute options, that stuff adds up. So a T2 micro, the standard on-demand pricing is going to run you about $8 a month. But if we look at the spot pricing, instead of 0.0116, it's going to be 0.0035. With spot pricing, that thing's going to be $2.50 per month. So this is a small scale example, but it goes to show you can save a lot of money with spot. Check out spot instances. They're very useful for saving money. We're not going to do it in this lab. I'm going to do it on demand. I'm going to leave all this stuff default. Most of this is mostly advanced stuff. You don't need to change this a lot of the times out of the box unless you have specific things you want to change. But the one thing I do want to use is down at the bottom, this thing called a user data. So if you are an automation junkie like me, and you kind of require some automation capabilities in the system, you will find yourself using user data heavily. So this is basically the cloud init capability, which isn't new. You can do cloud init on hypervisors on premises. This capability has been around, but on AWS, this is a really powerful capability. Pretty much any form of automation or configuration management is making use of user data in some capacity. So when we're launching workloads on EC2, 95% of the time, we've got something in the user data, even basic. If you're already using something like Puppet or Chef, this may be download my keys to the Puppet or Chef server and then bootstrap with this cookbook or manifest or whatever the terminology is. This is typically the entry point to either injecting other tools or doing full configuration of a server. So in this case, I'm going to use the cloud init built-in syntax to include what appears to be a shell script. I'm going to paste that in and we'll see it. Oh, downloaded. Let's move my bootstrap script into here, and let's move my Lance ID.pem into here. So not to go too nerdy on you, but I just wanted to show you, right? So this is a little cloud init syntax. We're going to reference the shell script that AWS is providing to us. I've downloaded it on my laptop so we can see the contents of that script to see what it's doing. And while this instance is launching, I'm going to talk through it. So I'm going quick because I'm used to this thing, but this is basically the storage page. So this is where you say, you have a root volume where the operating system currently resides, and you can choose to put whatever size you want there. You have different options for the storage components, which we'll talk about in later content. And you have different options to pick and choose, like the actual disk, right? Do you want kind of the standard, the slow magnetic ones? Do you want enhanced IOPS or like the general purpose SSD? We're going to stick with GP2. Actually, let's do GP3. Options for encryption if you need them. You can add new volumes if you need them. I don't need them at this time. But this is where we set up our storage components. Tagging is a very useful construct for capturing metadata about your workload. You can do tagging on almost all the AWS resources, and it's really useful to track what is what. So in addition to a name, so like seeing what the thing is in the console, I might say team, immersion, or no, I'll say mission. We'll say event, immersion. So in using this little metadata component of tags, we can basically assign metadata onto the workload, and to be able to both do reporting and see like the costs and the usage of the different parts of the system, or even administration and management. I could pull a list of all servers matching a specific tag and set some automation for those things. For example, like the backup service earlier. I may want to back up all servers with a particular tag in a certain way and maintain different tags for different backup options. So this security group we're also going to talk about later, but essentially this is kind of a firewall rule set that you can apply. It gets applied to the Elastic Network interface. So this is basically the firewall outside of the server itself, and what traffic will be allowed to pass to it. And expand. For this lab, we will need SSH open, and we will need HTTP port 80 open. Normally you want to lock down your management ports like this, but for the sake of this lab, I'm going to leave that as is. I'm going to review and launch. I trust that I did it correctly, and I'm going to pick my newly generated key pair, Lance ID. And I'm going to launch that instance. So it's only going to take a minute to come up. Right now it's pending. While that's going, I want to pop back to this little shell script. So if you don't speak shell, I will translate for you. So the first, basically when this server, now that it's coming online, we see it's pending in our console. It is now going through this script and doing these things. So it's first going to install a web server, Apache. It's going to install MySQL database engine, PHP, post hypertext processor. I forget what it stands for. I think that's it. And we're going to install a MySQL binding for PHP so that so that PHP code that we're going to run can interface with the MySQL server. So we're going to enable the web server. We're going to turn it on and make sure that it's running. Then we're going to go into the default path where the web server is serving HTML files from. And we're going to download another thing from AWS. We'll see it's on S3 in the Immersion Day Labs bucket, and it's a tarball called bootcamp app.tar. We're going to untar the tarball. We're going to change permissions of the configuration file here, and then we're going to update the machine. So it looks like our instance is now running. Because we included that little user data snippet to include that shell script, it executed the script, it ran through the instructions, and now you'll see if I'm going to grab the public IP address of the machine, and I'm going to go over to my new tab and paste it in, and we will see something load. So this is that web service, right? So when we installed Apache here, that's now the port that we're hitting. Looks like we got a broken image. I think this happened last time too. Yeah, that logo is being pulled remotely. It's not part of that tarball. So it's fetching it from a different S3 location, which I'm guessing.
Yeah, I think it was the old logo from the old AWS branding, and they just took it off, but didn't update the path.
Bummer. We'll just have to deal with a broken logo. No big deal. That was basically the thing we wanted to showcase.
Yeah, take notice, AWS SAs. They need to update it.
We may have to like patch this thing, inject a little extra user data there to use a different logo. Okay, so we've got a server up. It's running. This is the part where I go off script real quick. I've got a couple more minutes for this lab to conclude. All right, let me make sure that was the content. Yeah, that was it. So now we're gonna do the cool part. So I've got the public no, I don't. Now I've got the public IP address of this machine, this instance that we've launched. We can hit the web port, but now I want to do some actual administration. I want to get onto the machine myself. So I'm going to first set permissions on my key pair. So I want Lance ID, chmod 400, and I'm going to SSH to this IP address. This was an Amazon Linux instance, so the default user is going to be EC2-user, and I want to specify my key pair, Lance ID-.10. It's the usual fingerprint check, go through, and now I'm on the machine. So, when I initially connect, I'm this, EC2 user, kind of restricted, but I do have the ability to elevate to root permissions. So I've got root ownership of this server. This is mine to own and control. All of the configurations of the machine are mine to manage and maintain. And even the infrastructure around it, right? The security groups, the configurations of the machine itself, these are all mine to manage. We'll talk more in depth about the shared security model and like where the roles and responsibilities lie. But for the most part, just to kind of summarize it, AWS is managing the underlying foundational infrastructure, but customers are required to manage and maintain their own AWS deployment. So AWS is not going to be privy to the security groups that you're launching and the ports you're using. You could, in theory, open up all the ports to all the services and expose everything on that machine by accident. And it will be entirely your responsibility to take ownership for and to maintain yourself. Alrighty, so on this box, I think last time I was poking around, just kind of showcasing more on this system. When we did that cloud init user data script, the logs of everything that happened during that startup time get stored on the server. Normally there's two. There's var log cloud init.log, which if I cat, we'll see a bunch of metadata looking stuff. So this is basically as this server came online, go through these instructions. So that we're seeing basically the user data play out in debug mode essentially. And the server comes online and it's dynamically generating SSH key pairs based upon the one that we picked. We'll see references to when it downloaded the bootstrap, that script, and went through those, that little shell script, mounting our storage configurations and our file systems, and just kind of basically this is the server turning on and then running that custom automation. The other one is an actual output log of the shell script itself. So this, here we actually see, this is what we would normally see on the shell if we were to run those commands manually. So where we installed PHP MySQL and PHP MySQL, here we see the output for that. Right, so here's the packages, here's HTTPD getting installed, all the dependencies for those packages. MariaDB is the open source MySQL. We see all the packages getting installed. We see symlinks being set up for our services, system services like Apache running. We see our wget command fetching that tarball and storing it. We untar it and move it into our web directory. So var dub HTML. So if I navigate into there and I just do a directory listing, this is the contents of bootcamp app.tar. So this is what that shell script had pulled down. It's a handful of PHP files. If we kind of inspect some, we'll see there's kind of a simple index PHP script, which includes others. So as we are viewing this little web server, we're able to see the instance ID and the availability zone. It's interesting to point out that when you're launching compute instances, there is a component called metadata in which the compute instances they have awareness of where they are in the AWS ecosystem. And so this metadata, it's kind of a unique, this is specific to AWS's implementation, but any instance you deploy will be able to find the metadata at this IP address, 169.254.169.254, and I think it's slashed latest, dash metadata. So I'm going to curl it, right? So this again is a unique to AWS thing, but this metadata service is available to all compute instances. And when you get more into the advanced stuff and you've got IAM roles or instance profiles assigned to your instances, those things are going to be making use of metadata. And so you'll find that all of these little responses here are things that we can ping or poll. So I could say public IPv4, and there's the IP address of my EC2 instance. I could say instance ID. And so this, my terminal is making it show funny, but this is the instance ID of that of the server we launched, right? So if I find it, we see the text highlighted there. All of the running context of the server can be discovered through this metadata. And so instances become acutely aware of themselves and other instances. So this metadata can be useful for customers to build upon. We can see in this example, this PHP application is in fact making a curl request to the metadata in this exact route. If I find it, I forget which one it was in. I think it's in get index metadata PHP. Sounds likely. Right, so we see it here. So in this little PHP script, we see a variable being set for that same path, 169.254.169.254/latest/metadata. And then down below, it basically just appends the specific thing to see. So this PHP code is pulling the instance ID and the availability zone. It's pulling those out of the metadata endpoint and then rendering them into the HTML like we see here. All right, cool stuff. So the lab does not call for shelling under the machine and poking around. I just like to do it to showcase some of the behind the or the under the hood stuff. That was kind of a typical example of spinning up an EC2 instance, but of course there's a lot more options and capabilities to choose from. We just wanted to pick a straightforward example to showcase. This is how easy it is to spin up an instance, get something deployed, and then spin it down when you're done. I'm going to terminate my machine, and we will see it shutting down. I'm not sure if it'll tell me how long it was alive for. Oh, launch time right here, 12 minutes. So I just paid for 12 minutes of that compute instance. I didn't have to lock in any pricing. I didn't pay for capacity that I didn't use. I spun it up. It lasted for 12 minutes before I deleted it. And now when I get my billing statement at the end of the month, or when the billing metrics populate tonight, I will see charges for 12 minutes of EC2 runtime for a T2 micro. Cool. And now that machine is terminated, and in an hour or so, it will disappear completely from my console, and it was like it will never have existed. Cool. That is the EC2 lab. Let me check if there's any questions. I don't see any. If you have any questions, if you need help in the lab, or you got anything you want to call out, please chat it in. Please throw it into the questions section. If you got anything, I'm happy to address. Otherwise, I'm going to pass it to the next presenter to resume our talks.
Hey, thanks, Lance. Hi, by the way, this is Chandler. I see that this is a very interactive session, immersion day. We want people to be able to do the hands-on and not just take a look on what we do on our console. So I see only like few people logging to the AWS console. So if you guys receive an email, and you should have a link to how to log into the AWS console, and this is totally free. You can use the compute resource until tomorrow, so you can play around with the compute, the AWS real stuff by yourself. So if you have any trouble logging to the dashboard, let us know, and then we will help you to help you logging. So before, like, we still have a couple more lab to go, so make sure that you are able to log into the lab with us. Thank you.
Hello, everybody. Can everybody hear me okay? Do I sound all right?
Yes.
Okay, great. Yeah, so that was our friendly neighborhood AWS solution architect popping in just to remind people, yeah, you're going to have, the cool thing about doing these labs is you don't need to set up an AWS account, which means you don't need to necessarily give AWS your credit card, which you need to do when you set up your initial account. These dashboard, or this event engine account lets you go into the cloud and just start playing with things and building stuff, all on AWS's dime. So if you want to go in and start playing with the console a little bit, if you've never been into the console, using the accounts that we sent out is going to be a really great option for you. And I think they set the self-destruct, as they said, for 24 hours. So all these labs that we're sending out to you, you can do these on your own. You can do them with us today. You can work on them tonight. You can do them tomorrow, wherever you feel comfortable. So yeah, take advantage of free AWS console access when it's made available. So hi, my name is Brian. I'm going to take you guys through a overview of cloud storage. Let me fire up this presentation. I know everyone's going to get slide fatigue, so I'll try and get through this quickly so we can get into the console, start playing with some things, and then go to lunch. So we're going to do a flyby on storage on AWS. Now, disk and storage in the cloud is pretty straightforward, as you're going to see, but translating what everyone's kind of used to in the on-prem and data center world to what's available in the cloud is where I think the value lies and what we're going to talk about today. So we're going to go over a quick introduction. I'm going to give you a storage primer. We're going to talk about the different storage options in the cloud, and I'm going to show you guys a couple of the services that are key for extending or making kind of a bridge between the storage in the cloud with your storage on-prem. Okay, so this slide I think is this slide is entertaining to me on a couple of levels. So it says, why choose AWS for storage? The why is a little questionable because when you use AWS, you have to use AWS for storage. You have to use the local AWS storage technologies when you're in the AWS cloud because everything is integrated. So long story short, you don't really have a choice of what storage options when you're in the cloud. However, a lot of companies decide to extend their storage on-prem and into the cloud. So you can actually use AWS as your infinite garage of storage and not necessarily launch additional workloads in the cloud. So one of the things about this slide is I think the pitch here is a little bit of like, if you're not going to fully migrate and put everything into the cloud, you can use AWS as a storage plane or an extension. You know, you can do all your storage in AWS. You can make an extension of your on-prem storage. There's a lot of different pathways and options to kind of like wade into the cloud storage world without moving all of your servers and moving all of your databases. And we'll get to some of that later in this deck. So I'm going to highlight a couple of these key points in this slide. So the pay-as-you-go is something you're going to hear across all AWS services. You know, AWS's billing is like the analogy AWS always likes to use is like a power bill. So you flick your light on for 5 hours a day. You're only getting charged for those 5 hours that you turn your light on. It's the exact same thing with cloud storage and many of the cloud services. So you're only paying for all the storage that you consume. I know in the on-prem and data center world, I actually have like 10 plus years working in very large AB data center worlds. And that is not how it works with storage in the data center world. You pay for how much storage you bought. Whether you use it or not is a completely different story. So AWS, you're only paying for what you actually consume. A big one I want to highlight here is the no risky capacity planning. So I know from my own personal experience working in data center world, we used to run reports on how much SAN was being actually used by application stacks and application clusters that were provisioned for those resources versus how much was actually consumed. So we, in the data center world, a lot of it is, hey, we're launching this application and we want 300 gigs on our server. But then when you run a report, you find out they're only using 20, right? So the capacity planning is tough because people always almost over provision and then underutilize, where in the cloud, you don't need to do that. So you can have, there's certain storage services that will literally grow and expand as you add more data into those services. So they just grow infinitely. So you don't have to plan your capacity. You don't have to go, oh, next year we're going to have to buy this much X more storage because of our growth rate or things like that. So it kind of takes out all capacity planning when you use some of the elastic storage services. There's another note there. It says no need to provision for redundancy or overhead. Now that's the case when you're using some of these services where redundancy is built into the storage service. So when you're just using the service, you already are getting multi-AZ, and you're getting replication across multiple data centers within a region. So you don't need to plan the redundancy. You just use the service that has the redundancy. Let's see. Is there anything else I want to touch on this? Global scale is a big one. I mean, you can move your data and put it really anywhere in the world, wherever there's an AWS region. So let's move forward. So everything in storage in the cloud kind of falls under three umbrellas: block storage, file storage, or object storage. So in the on-prem world, I'll kind of just translate some of these things so that you know from maybe running your own data centers or your own server farms or your own colos. Or your own SAN. So block storage, the AWS equivalent of block storage is going to be something you're going to hear a lot called EBS, Elastic Block Storage, or EBS. I don't know if it's service or storage, but EBS, Elastic Block. That is your typical SAN. So when you have say you have your VMware ESX silo and you're adding LUNs and then you're launching VMs and you're adding that disk, you're taking out the disk out of those LUNs and applying it to those servers. That's that block storage. The same kind of concepts work in AWS in the cloud. So when you launch an instance, like what Lance was doing in that lab demo, he was launching an instance and there was a storage screen and it said what volumes you want to add. Those are backed by EBS. So EBS is the actual attached block storage that you can put onto any of your compute nodes. Now moving down, file storage. This is your NAS, so your network storage, your network attached storage. In the AWS world, it is EFS, so it's called Elastic File System. So that is if you need to have one like NFS mount that's going to go across multiple Unix servers, or one Windows SMB mount that's going to go across multiple Windows servers, that falls under the EFS, under Elastic. Then the last one is the bread and butter. This is the one that is kind of really substantiates AWS's like storage footprint. It's the one everybody uses. It's called S3, and this is an object level storage. So S3 is just part of the ecosystem inside of AWS. If you start becoming an AWS user and a customer and you start experimenting, almost everything interacts with S3. And it's a global service, so S3 just kind of lives in every region, everywhere. Any service can go and hit it and talk to it and put data in there and pull data out, and there's a lot of cool things you can do with S3. And I will just touch on one thing: is when you do AWS certifications, whether you get like Solution Architect Associate or even Cloud Practitioner or any of the basically any of the associate level and pretty much all the AWS certifications, a lot of these three things are going to be covered, especially S3. So when you do training for AWS and you're going to get certified, you're going to learn all the little nuances about S3, EFS, and EBS. So the three storage, the big three storage options inside AWS are very important to kind of understand and learn, especially if you're going to get certified. All right, so some of the storage characteristics, we already talked about a few of these things, but the two things I want to touch on the most is durability and availability. So when you talk about storage, if there's any people here who manage storage right now, you know all this stuff. So I'm just gonna maybe touch on it still. But durability is how much data you can expect to lose over a certain amount of time, like data degradation, and then availability is how much of the year over like a calendar year can you expect that data to not be accessible. So we're going to touch a little more on how durability and availability kind of like translates into the cloud. So durability would be like if you want 4 nines, so when you talk about durability, you're going to hear like this number of nines, where 11 nines is the pinnacle. It's the biggest, baddest way of like getting the highest level of durability. But you can also design things for down that scale. So so when you say 2 copies of a piece of data on one site, you're going to get 4 nines of durability. But if you want that 11 nines, you're going to want to have 1 copy across all 3 available. Like in a region that has 3 availability zones, you want to use a storage service that's going to have copies of that data across all 3 availability zones. And when you do that, then you achieve the highest level of the 11 nines that everybody wants. So if you notice, there's like, you take 1 availability zone, have 2 copies there, you're getting 11 nines. You take that copy, put it across 2 availability zones, you're going to get the 5 nines, and then you blow it out to all 3, you're going to get the 11 nines. So obviously cost and changes when you go to the higher durability, but for production workloads and really important stuff, that's something you want to keep in mind, how to achieve that like 11 nines of durability using the native services. So here's a little chart that says like how your availability goes down, which is a number you want to go down. So the higher number of availability means that's how much unavailable time you can expect in a year. So as you have the 5 nines, your data might not be accessible for 5 minutes total throughout the time period. But as you add the durability, as you use more of the like multi-AZ services, as you hit that 11 nines, the availability goes way down, which means that data is almost going to be always accessible all year. This is just kind of this slide has just a lot of different flavors of AWS offerings. So we already talked about like under block storage, there's different types of block storage. We're going to touch on some of this. So when you decide to add a physical volume to a compute instance, AWS has no shortage of options. So it's not just you're going to attach a volume to a server. You're going to have to pick which flavor of volume you want to attach to a server. And you're going to hear a term or a phrase used a lot in AWS or in the cloud in general, where it's like pick the right tool for the job, right? So if you have a really performant server and you need high input output, you're going to probably pick a more performant type of block storage, where if you just need regular block storage, you're going to use like a general purpose. So AWS has a lot of different shades and colors of things that you can apply to make really fine tune your workloads. So the block storage is there. File storage, we're going to talk about EFS, and then on S3 we're going to talk about. So we're going to go a little deeper on all 3 of these. But this is just kind of a Venn diagram of how these all kind of interact. Now the rehost, replatform, rearchitect construct, I'm not going to dive too deep into that. Your AWS SAs would be more than happy to kind of explain like what the difference, when you're migrating into the cloud, there's different pathways you can take. Do you just want to rehost your application? Like, do you just want to lift and shift? Do you want to replatform, meaning do you want to take components of your workload or your applications and start using some of the cloud native services in tandem with like, just running a server? And then, a full re-architecting is to just use everything cloud native and, totally ditch, your old kind of old stack and old way of doing things. I don't know why that S3 bucket is just sitting down there and re-architect by itself, because I think S3 is really a service that is going to be around no matter what you do. But anyway, we'll move forward. So we're going to talk about the 3 big storages. We're going to talk about block, file, and object. We're just going to do a flyby on these. So EBS, as we were talking about the EC2 instances, or just any compute node in general, you're going to attach an EBS volume to that server. The cool thing about EBS is there's a lot of cool things about EBS. EBS is designed for 5 nines out of the box. You're getting redundant storage. You can secure all your EBS volumes using like individual policy, using the global IAM. If you guys don't know what the IAM service is, you're going to hear about that later today under security. So I'm not going to dive too deep on that, but just know that IAM covers EBS volumes. Scalability, capacity when you need it. So EBS is not an elastic volume service. You have to pick the size of your EBS when you attach it to a server. However, you can grow and shrink the volumes on demand and on the fly, and you can grow and shrink these volumes using API command line access. You don't actually have to go in a console. In fact, all your EBS volume activity can be managed through command line, which means you can script and codify and automate. So you can have all your EBS volumes attached to servers. Just one of the cool things like you can do is you can bring up a fleet of servers and then have EBS volumes that are attached, and say you need to destroy or bring down a server, you can bring that server down and then take those EBS volumes that are attached to that server and then automatically swing that over and attach it to a completely different server, different instance. So those EBS volumes can just kind of float around and move and reattach to any instance that you want anytime. You can take point-in-time snapshots. We're gonna dive a little bit into that. So EBS is a network attached block device. It's not physically attached to your instances. It's going to be attached over the network. Although they are so performant, they're going to look and feel like they are local to the server, even though they are not. One thing that is highlighted there in bold is only one EC2 instance at a time per volume. So that's a big thing, and that's actually like a test question in a lot of the AWS certifications is one EBS volume can be attached to one instance. You can't have one volume that is attached to multiple instances. That's just the way block storage works. It can be detached from an instance and attached to a different one, which is what I was just talking about, where the EBS volumes kind of are their own islands, and they just go and attach to whatever instance that you tell them to. And then there's different drive types. So essentially, EBS volumes come down to two different flavors. There's an SSD, and there's a couple different options in SSD, and then there's physical spinning disk hard drive. And there's a couple options in there. So when you pick your EBS volume, you get to pick your flavor. So do you want SSD? If you do want SSD, there's different options. And if you want hard drive, there's different options. And they all are priced differently as well. So this is a slide that just talks about what the different volume types are. So under SSD, you have two different volumes. Actually, there's three now. This slide needs to be updated. I apologize. There's so whenever you see numbers like GP2 or IO1, whenever you see numbers in the AWS world, that means the version of the current release of that product. So GP2 stands for general purpose 2. GP2 was around for many, many years as the de facto general purpose SSD block device. However, at reInvent last year, they announced GP3, which is a slight upgrade to GP2. So now when you go and attach a volume and you select SSD, you can pick either GP2 or GP3. There's only some very small nuanced differences between 2 and 3. But then the other one here is provision IOPS. Now, you guys don't need to all know the minute details about these, but just know that general purpose has a certain amount cap on IOPS, and then if you really have a super performant application that needs really heavy read and write, you can go to provisioned IOPS. It's a little more expensive, but it's way more performant. And you move over into the HD world, like the hard disk, the spinning hard drives. There's a throughput optimized, and then there's a cold. So cold is obviously going to be the cheapest. There's different use cases and different reasons to use all of these. A lot of this stuff, like I said, is covered in AWS certification exam, so you will be getting very intimate with all of the storage options for EBS if you ever do take cert courses. So there's just some of the use cases for these things. So SSD is going to be great for any kind of databases. Hard drives are really going to be good for file and media storage. You don't really need SSD for like doing transcoding. So there, like I said, pick the right tool for the right job, whatever your workload is. Either Mission or AWS Solution Architect can help you decide which is the right path to go to for designing these workloads if you're not sure. Let's see. This is a breakdown of all the different available options under EBS. I'm going to breeze through these because a lot of this stuff is just very technical, but if you're not into storage, you probably are not super interested in this. But essentially, what differentiates like the general purpose SSD versus the IOPS, the provisioned IOPS is the amount of IOPS that are available to these volumes. Now in GP2, if you say the baseline is 100 to 1600 IOPS, as you grow the volume, the IOPS, the amount of input output that those volumes can handle changes. So as you grow it, it can handle more and more IOPS, and then it hits a cap of 1600 when you grow the biggest, which I think is 16 terabytes. Well, don't quote me on that. So the throughput isn't something to note as well. It can go up to 250 megabytes. The GP3 has slightly higher stats than all of this, and it's slightly cheaper. So AWS really wants people to start using GP3 because it's a slightly cheaper version of GP2 and a little more performant. If you notice, provision IOPS goes up to 64,000 IOPS, and the throughput is much higher at 1,000 megabit. So if you have a really heavy read-write, you're probably going to want to look at provision IOPS. The cool thing is you can launch a GP2 or GP3 volume, and then if you don't like the way it's performing, you can actually upgrade and change the versions on the fly. So you can actually say, oh, this EBS, I want to convert it to a provision IOPS. So AWS is very flexible in that regard. Give me 1 second. My kids are being picked up by my parents right now. Okay, So we'll breeze through the hard drive versions. There's throughput provisioned, and then there's ST1 throughput provisioned, and then cold. So like I said, when you select your EBS volume, there's going to be a whole lot of options. So snapshotting. So snapshots is very important. You can take point-in-time snapshots of any of your EBS volumes and store them away, and those snapshots get stored into an S3 bucket. So, and all of those can be accessed once they're in a bucket through API calls. You can resize EBS volumes once they're put into a snapshot. So you can take a snapshot of EBS and then change what the type of EBS it is in the snapshot, and then reintroduce it into your servers if you want. A key thing down there at the bottom is copying snapshots across regions. This is also a popular exam topic question. So they say, how do you move an EBS snapshot from one region to another? Well, the way to do it is you create a snapshot, and then you can copy that from one region to another, and then reattach the snapshot to an instance running a different region. So that's why it's in there. It's a very popular exam question. So this is just a visual representation of how AWS does the snapshots. So you take your initial snapshot, which is going to be a full snapshot of the entire volume, and then the deltas are only going to be kept after that. And then you can clone snapshots. So say you launch another instance and you want the exact same file system set up that's in a running instance, you can snapshot it and then clone it back out. And then any changes made to these snapshots are going to be just deltas. So the additional snapshots are just going to capture the changes from the last snapshot you ran, which is pretty industry standard behavior for snapshotting. One thing we want to talk about real quick is a EC2 instance store. So this is a specialized EBS option. So say you need local caching or something that really is really heavily like read-write, and you want the fastest performance, but you don't necessarily need to save that information long-term. You can do what's called an instance store, where this is going to be a physical hard drive or a physical SSD that is going to be local right to your EC2 instance. So this is an option. People use this for like caching, for things of that nature. There's a lot of different use cases for why you would use an instance store, but there are some caveats with instance stores. Meaning, if you shut down the instance, any data in an instance store goes away. So it's not state. It says non-persistent data store. So there is like some trade-offs with using a instance store. But just know that, say you go, oh, I want to attach a volume, but I don't want it to be like a network volume. I want to actually physically attach to the host, then you would use an instance store. So that option is available in AWS. So I'm going to keep plowing forward. We're going to talk about EFS. So this is that shared file system. So this is going to be the cloud equivalent of your local NFS servers or your local network shares. Also SMB, so your Windows or your Linux shares. Now the EFS itself, Elastic File System, is going to be covering NFS. It's going to be covering strictly Linux or Unix-based workloads. AWS has a different service called FSX that does SMB, and that's all Windows-based. So we're going to talk real quick about EFS, and this is going to be the bread and butter for network attached storage for Linux. So it's fully managed, meaning AWS handles everything. You just create the Elastic File System and mount it to whatever servers or compute nodes you need it to. Works with standard operating system API. So like everything in AWS, it's all API driven, meaning you can run commands to attach, detach, create, shut down, destroy. Like any interaction you need to have with any of these storage services can all be done through API, which also means everything is tracked in the cloud. You guys are going to learn about that later in the security slides, how all of that is tracked. So anytime you make an API call, so anytime you create an EBS volume or an EFS volume, or you make changes, all of that, because it's an API call, is tracked and monitored inside of your cloud account. The key thing here is elastically grows to petabyte scale. So the nice thing about an EFS versus NAS, so I used to have to run NAS filers or have to interact with our NAS team, and the fun part about running a NAS server is the constant feeding of disk to the NAS server and making sure your NAS server has enough data to meet the needs of your users. So EFS takes care of that by you just create an EFS volume, put data on it, and as you put more data on it, that EFS volume, which it's elastic, it says in the name, it keeps growing out indefinitely, and you're only going to pay for how big your EFS volumes grow. So The nice thing is all of the capacity planning for your network attached storage is gone. You get to live a much happier life not having to worry about adding disk to your NAS servers. AWS handles all that for you. As you see, it's NFS based, so it's pretty common protocol. Now, the key thing down there is accessible from on-prem servers. Yes, you can mount EFS volumes in the cloud down to servers in your on-prem environment. That is totally doable. So EFS is simple. It's fully managed. AWS takes care of all the heavy lifting to maintain your EFS volumes. Seamless integration, so it just uses standard NFS. So it's just the same kind of NFS mounts are NFS mounts. It's all pretty straightforward. AWS is no different with EFS. Works with standard OS file system APIs. Simple pricing, simple forecasting. This is, all the pricing is very transparent. You go to the EFS page, find out how much price per gig, and you can pretty much calculate how much your EFS volumes are gonna cost. I already talked about EFS being elastic. It can grow and shrink automatically, meaning you don't have to provision a size for your EFS volume. You just make the ES volume, put data in it, and it grows and shrinks for you. We already said it grows to petabyte scale. As your EFS volumes grow, the IOPS scale with it, so you don't have to worry about or even think about your IOPS the IOPS capabilities within EFS. It just does it automatically for you. Support for thousands of concurrent NFS connections. So we're going to talk about that in a minute. It's designed to sustain easy offline conditions. So the nice thing about EFS is it has that durability built in. So if one of the AZs is experiencing EFS outage or an issue or some kind of service interruption, EFS is designed to be able to handle an AZ being offline or going down, and your network attached volumes won't have an outage. So that makes it appropriate for production applications. So this is just an example of EFS mounting. So you have your DNS name of your EFS volume, and you use your regular old Unix mount commands, and you just target the URL or the network name of your EFS volume and attaches. Now, EFS has options for lifecycle management. We're going to talk a little more about lifecycle management when we get to S3, but you're going to hear a term called standard, and you're going to hear a term called infrequent access. So infrequent access in the AWS world means we will charge you less to store it, but you can't access it as much as you want. Let me rephrase that. It's that we'll charge you less if you access your data less. So if you just want us to store the data, but you're not going to be actually retrieving it very much, we'll give you a discount. So that's what infrequent access means. They'll charge you for each time you read or pull the data, but they'll give you a major discount for storing it. So standard and infrequent access are on the same storage tiers. It's just a pricing difference. Infrequent access is not less performant than standard. AWS just wants you to move to infrequent access and then not access your data. It's like just we need to store stuff. We need it to sit there. That's when you'll hear IA being recommended. Now, with lifecycle management enabled, EFS automatically moves files, not accesses. So this is a lifecycle management. There's a lot of different approaches to take with lifecycle management, meaning you set up policies around your storage and your data that says, if something happens, do this. So in this example, it's saying when you have users or applications that put data into an EFS volume, if no one's touched the volume or touched the file for 30 days, move it to infrequent access to start accessing some of those cost savings. So there's a lot of things you can do with that with EFS and S3. So there's a lot of options for lowering your bill as far as that goes. FSX for Windows is the Windows version of EFS. So this is a completely different service than EFS, but it's essentially the same. So if you manage SMB or Windows file shares, it works the same. You go into AWS, you create your FSX file systems, you attach them to your Windows servers, and you still get all the same scalability. It works essentially the same as EFS, but it just runs over SMB. The FSX for Windows runs on Windows Server, so the backing is all Windows Microsoft products. Uses the native SMB protocols, can interact with your Microsoft Active Directories. Now we're going to talk about the bread and butter S3. So object store is what really makes AWS live and breathe, especially this is a S3 is an Amazon specific service. This really is a differentiator for AWS versus other cloud providers like Azure and GCP. So let's talk about it. So S3, it's web accessible, although by default, global access to the web is denied. So, but you can make a bubble. You can make a bubble. I'm sorry, tripping over the word. You can make a bucket public, although it is always going to be non-public by default. Just FYI. That's also an exam question. Highly durable, meaning it's got that 11 nines of durability designed into it. Limitlessly scalable. I'd like to see a company push AWS on that. But you can essentially grow a bucket or buckets as big and wide as you want. Multiple tiers to match your workload. So we're going to talk about those tiers in a little bit. I already touched a little bit on data lifecycle, where you have policy that says when something happens, do something to your data. All that works in S3 as well. Static web hosting. A lot of websites in the world are run off of S3 buckets. So one of the cool things about S3 is it can be a storage location for websites, and then you can use other AWS services like CloudFront to use to serve out the static content on a bucket, which means you don't have to run a web server. So if you don't want to run Apache or IIS, but you want to host a website, S3 is a great option for storing your website and running a cloud-based website right out of S3. The big thing is security, compliance, and audit capabilities. S3 has a ton of security options. It's completely covered by IAM. Everything you do in S3 is API driven. So every time you touch, move, read, anything done in S3 can completely be logged and tracked. That also gives you pretty much it gives you a high ceiling for auditing. You can audit anything that happens in your buckets. And then the storage pricing is standard. S3 pricing is pretty easy to figure out and calculate. And then the pricing can change and fluctuate based on whatever storage tiers you want to use, which we'll talk about. So here's a chart that talks about the storage tiers. Now, when you make a bucket, you can decide what tier you want that bucket to live in, and that's just going to change the amount that it costs you, and it's also going to change the way you access the data. So S3 standard is kind of the basic, when you make a bucket, it's going to be the most expensive, but I mean, it's also extremely cheap, but out of the other storage options, it's going to be the most expensive. As your frequency of how often you need the data goes down, the price is also going down. So I want to focus real quick. So you go from S3, then you go to standard infrequent access. So infrequent access is the next tier where you're going to be charged for retrieval free, but you're going to get a lot less cost for actually storing the objects. Then if you, so the difference between standard IA and one zone IA is one zone IA says we'll give you an even bigger discount off of standard IA if you only need that data replicated, or not, you don't need that data replicated. It can live in one availability zone, so which means your durability goes down, but also your costs go down. So standard IA, you're still getting that multi AZ durability, so you're getting that 11 nines when it's going across all your availability zones. But say you have data that's not that important, and if it goes away or it's not available because there's an AZ outage, you don't really care that much. You want to keep the data, but it's not like really critical. Moving it from standard IA to one zone IA will save you some money. And then if you want just deep storage, then you're going to start looking at your Glacier options, and they have two options in Glacier. They have regular Glacier, and then they have Deep Archive. So Glacier and Deep Archive get really cheap, but you have a longer retrieval time to get to your data. So if you notice in Glacier, it says select minutes or hours. You can, meaning if you request an object out of your S3 Glacier bucket, you can set that to like, I'm gonna request the object, but I'm cool with it not being available for like 2 hours. That's gonna give you a really heavy discount, but also you gotta wait your 2 hours to get your object. And then Deep Archive is 12 to 48 hours. So if you're saying, this data, I want it really, really cheap, but we want to hold on to it for a really long time. And when I request the object, I'm totally fine waiting, 12 hours to 2 days to get my data so I can actually access it. That's where Deep Archive comes in. So a lot of different options on the tiers inside of S3. okay, so this is some of the S3 management features. So when you take your AWS certification exams, all of this stuff's going to be covered. You're going to learn a lot about all the nuances around S3. S3, all the objects in the buckets can be tagged, meaning you can assign metadata to the object, like billing departments, people, projects, environments. All that stuff can be tagged inside your S3. Prefixes is essentially folders. So when you see the word prefixes, it's meaning like, because objects are all flat, but you want to create them and organize them into folders, like you would in like your desktop file system. That's where prefixes come in. Versioning is important, so you can track every time a new version of these objects are uploaded, and you can keep a history of those versions. Everything inside of S3 is monitored by the native AWS services, which is CloudTrail and CloudWatch. You're going to learn a little more about both of those later on in security slides. Replication, like I said, there's a lot of different tiers. There's intelligent tiering. So one thing I didn't talk about on that last slide was that intelligent tiering. So intelligent tiering is a service that AWS launched, I want to say 2 years ago or 3 years ago, where AWS's AI machine learning will, if you turn on intelligent tiering, it'll look at your behavior patterns within your buckets, and in AWS will decide where to put your objects. So if you're accessing your data a lot, it'll keep you in standard. If it notices you're not accessing it very often, it'll automatically move your stuff to infrequent access. And if you haven't touched this data in a really long time, it'll just start sliding things into Glacier. So if you turn on intelligent tiering in your buckets, you just sit back and AWS's machine learning will decide how to manage your data for you. So that's where intelligent tiering comes in. I just want to bring that up. Modify. So what's cool about S3 is anytime a bucket or an object or something happens to an object, it can be considered like an event, and that can trigger things in the cloud, which if you guys don't know what Lambda is a serverless, it's a serverless operating where you can just run code based on triggers and events. You don't need to spin up a server to run some code. Lambda can just do things for you. So I'll give you an example. So say you have a process where you have an image that gets uploaded by users, but you want to add your corporate watermark to an image, right? So how this could work is you could have your application drop the images as people upload them into a bucket, and then the bucket creates an event, and then Lambda is sitting listening for any event coming from this bucket, and the event triggers the Lambda to then kick in and use, PHP or Node or whatever, JavaScript, something to attach that watermark to the image and then put that image in a different bucket. So, you can trigger and do workloads around bucket puts and reads and all sorts of stuff. So a lot of fun things you can do with S3. Let's see, access management and security. I kind of already touched on this, but AWS's security service and access management, IAM. You're going to hear more about IAM later and kind of what it is. But IAM fully covers S3, whether it's users, policies, making sure people can and can't get to certain buckets or even objects within the bucket. Access control lists are just, you can set global access control lists over entire buckets. Also, they have S3 bucket policy, which is its own policies native to S3. So the difference between ACLs and bucket policies, there's some nuance there, and all that stuff is kind of covered under AWS certifications. AWS Macie. So you're going to hear about Macie in the security deck later on, but Macie is an AI service inside of AWS that can actually traverse your buckets and look for bad things. So if you have you don't want your application or people putting credit card numbers into certain data sets inside of buckets, you can say, hey, Macie, tell me anytime credit card numbers are put into a bucket, or tell me anytime PHI is put into a bucket, or tell me anytime people are suddenly moving large data out of a bucket, when any kind of weird or abnormal behavior Macie can also pick up on. So Macie's a cool service that kind of can cover your S3 bucket security. The last thing we're going to talk about, now we've kind of talked about the AWS native services, is how do you integrate your AWS, some of these AWS storage services to your on-prem environment? Because the truth of the matter is we kind of live in a hybrid world. Most people aren't fully cloud native. Most people still have their colo, they still have their data center on-prem, they still have their corporate office or whatever. So how can you leverage AWS's storage services while still using your on-prem environment? when I worked at AWS, almost all of our enterprise customers still used AWS and their data centers, and a lot of these storage services we're going to talk about kind of help bridge that gap, and we'll talk about a few. So there's a lot of options for moving your data from your on-prem environments or even other clouds and into AWS. This is just kind of a sweeping a subset of some of these services. As you get into AWS, you're going to learn that it's service soup. They have 290 plus services right now, but the key one we're going to talk about here, the key ones is going to be the AWS Storage Gateway that's highlighted in yellow. We're also going to talk a little bit about Data Sync and then a little bit about Snowball. So Storage Gateway is a really cool AWS service. I think this is one of my favorite services personally. It essentially lets you set up a virtual appliance in your on-prem environment, and it lets you do 3 different things. There's 3 flavors of there's three pathways to go with AWS Storage Gateway, but all of them essentially extend the AWS storage services in the cloud into your data center. So you can do this through tape backups, volumes, or actual just file system mounts. So we're going to talk about the 3 kind of flavors of Storage Gateway. So Storage Gateway, like I said, has 3 flavors: File Gateway, Volume Gateway, Tape Gateway. I'm not going to go super deep into all 3 of these, but just know that Storage Gateway, essentially you go and you download a Storage Gateway, a virtual appliance, and also there are physical appliances you can get from, I think, third-party vendors. However, most people use the virtual appliance. So you download this virtual appliance, launch it into your VMware environment on-prem. Then the Storage Gateway communicates and talks back to your AWS account. And then you can pick, do you want to start using the File Gateway, the Volume Gateway, or the Tape Gateway, or all of them? So the File Gateway essentially is an NFS extension. So you can mount AWS volumes as local NFS volumes on your on-prem environment. So essentially you can just start using the cloud as your garage for data. Volume Gateway lets you attach actual block interfaces as iSCSI devices to servers and other storage solutions that you might have in the cloud. So instead of running like a NAS, this is going to be an actual physical iSCSI attachment. And then Tape Gateway lets you, if you're using tape backup services, you can use AWS's storage services as just iSCSI virtual tape library interfaces, so VTLs. So you can add cloud-based VTLs into your existing on-prem VTLs and then start having some of your tape backups being stored in the cloud, which is a really great option for disaster recovery. So why would you use Storage Gateway? Uses the standard protocols, like I said, uses NFS, uses iSCSI, uses VTLs. Local caching. So some of the options inside of Storage Gateway, especially I think with File Gateway, is if you have stuff in an S3 bucket and your people on-prem are accessing those files often, those will actually be cached on the Storage Gateway's memory so that the latency to hit those objects that are actually over in the cloud is going to be a lot faster. So there is caching options inside of Storage Gateway. Stateless virtual appliance, meaning that the virtual appliance can be brought down anytime you want. So I already touched on the flavors, but this is just a diagram showing like what does File Gateway look like. So your File Gateway is the actual Storage Gateway appliance running as a File Gateway. It's actually going over the wire and communicating with S3 and accessing those S3 buckets, but it's presenting those buckets as NFS volumes to your local servers. So this is a really cool way of, if you have an on-prem environment and you're kind of running out of NFS storage and like you're worried about capacity, start using AWS. Use AWS as your infinite storage garage for some of your data. Why not? It's cheap, and you don't have to worry about stuff going down. So this is the Volume Gateway. So it's the same thing as on the left, your on-prem environment. You have your Storage Gateway running as a Volume Gateway. It presents your iSCSI devices, and you can attach that to ESX silos, or you can attach it to actual individual servers, whatever you want. Just use the standard iSCSI. And then the last one, Tape Gateway, supports all the tape backup systems like Veritas and Veeam. It uses the same thing. So your iSCSI, so your backup servers are just going to see your Tape Gateway as a media device through iSCSI, and you can just put your VTLs there. So, and then those can get stored over into S3. And then once you're in S3, then you can pick like, oh, do you want to put these in Deep Glacier for long-term storage? It can really extend or replace your tape backup systems. So this is just a summary slide. I think we talked about a lot of these. using it for backup, DR, using Storage Gateway is a great backup, great DR solution. A lot of companies don't fully use AWS, but they will use Storage Gateway. They're like their SAN, their NAS, their backup teams will use Storage Gateway as a cloud hosting platform for their backups. So the last, another service I want to touch on real quick is AWS Data Sync. So say you need to just it's kind of like an R copy or RoboCopy, or say you just need to move data into a bucket or into a volume really quick. AWS Data Sync essentially runs an agent locally in your on-prem environment. It's super fast. This just looks at, you launch a data sync agent, you point it at a file system, you tell it to start copying over to your cloud, and then it can go replicate that data over to a bucket or to a EFS system. The difference between this and Storage Gateway is this is just a one solution of just copying data from NFS over into a bucket. It's very simple. It's really fast. Storage Gateway gives you a lot more options. It gives you options you can't do caching with Data Sync. You can do caching with Storage Gateway. So I would say Storage Gateway is a more fleshed out kind of enterprise level solution. But if you just need to start shoving data from on-prem to the cloud and get that data synced, Data Sync is an option as well. Now, the last thing we're going to touch on is Snowball. So say you have a ton of data and maybe your network connection isn't so good, or you don't want to take the time to copy a bunch of data over the wire and into the cloud. Maybe you're worried about security. Maybe you're worried about how long it's going to take. You can order or request a Snowball or another version of Snowball, Snowball Edge. But essentially, this is a big physical box that AWS will send you, and then it'll let you plug it into your network. Then you're gonna, I'll show you what it looks like. So this is what Snowball looks like. A lot of companies love this thing. It comes to your office. It's got RJ45 port. You plug it into your network. You launch a Snowball client on one of your machines in your network that's got access, and then you tell that client where to start grabbing data, and it puts it on the Snowball. Then you mail it back to AWS. Then they integrate and put all that data out of the Snowball and into an S3 bucket. So they come in two flavors. I think they come in a 50 terabyte and an 80 terabyte version. These things are bigger than they look. So when you see one in physically, they're you think they're small, like a lunchbox, but they're actually big, I don't know what a good analogy is. Maybe like a large briefcase or something, but they're pretty big. They're pretty heavy. They're extremely ruggedized. They actually have, I've seen them. They have Amazon Kindle. So they have a Kindle built in with the UI. So it's you get in, you log in, you give it your credentials, your security keys, verifying you are who you say you are. You launch a client. The client talks back to AWS, says, okay, I got my Snowball. Here it is. It's on the network. I'm talking to it. And then you can start putting the data on the Snowball, and then the Snowball goes out to AWS, and it magically shows up in a bucket. There is a Snowball Edge. So if you saw a thing called Snowball Edge, they have a more intelligent version of Snowball that actually can run some compute layers on Snowball Edge. I'm not going to dive into that, but just know that if you actually want your Snowball Edge to act as its own file server versus doing everything through a client, that's where Edge comes in. So Edge can actually host and be its own file server, whereas regular Snowball, you have to use a client. So there's some differences between Snowball and Snowball Edge. Data is fully encrypted, obviously. This is just some charts saying how fast can you get your data up into Snowball. If you're using connection speed, this is just some of the data on how fast it would take. I honestly don't really remember how to read this chart. Last thing I want to talk about is Snowmobile. So say you have a really massive data center and you got exabytes of data and you need really, really big data integration. AWS will literally send a truck to your data center. I don't remember the capacity limits. I'm sure it's changed, but I think it can go up to 100 petabyte transfer into this thing. I'm sure that might have changed by now. But what's cool about the Snowmobile is when it pulls up into your data center, they actually have a network switch, like a full-on high-speed network switch that they go and take into your data center, and they integrate it into your network. And that network switch has a connection right out to the truck. And then you point that network switch out to whatever you want it to suck down and put it into the Snowmobile. And then the Snowmobile drives to one of the most closest backbone entry points for the AWS network. And so it goes to wherever the closest backbone link is, and then it dumps all the data into the AWS backbone, and then you say, oh, where do you want all this data to go to, which region and your account, and then it goes into your account. So large, big time data center migrations definitely happen with Snowmobile. And that's, I think, it on data on storage. So I think we're gonna jump right into the AWS lab on S3 real quick. Let's see how we doing on time.
We do have a question from
Sure.
Malik. Can you explain the functionality of the EBS multi-attach feature?
Okay, so Elastic Block. So EBS multi-attach feature. I'm gonna have to look that up because EBS is meant for a one-to-one attachment. So one volume can only be connected and attached to one instance at a time. So EBS volumes can't be shared. However, they can be moved and migrated around in between instances. So if EBS multi-attach is a feature that I'm not aware of, I might have to Google this. So I apologize, I don't have a good answer for you. Maybe Lance does, or one of the AWS SAs can pipe up, but I'm not sure what EBS multi-attach is.
Yeah, it's a new thing.
Okay,
So yeah,
there you go.
Historically, you've only ever been able to attach one EBS volume to one instance at a time. So multi-attach is a new capability for IOPS enhanced disks, so IO1 and IO2. You can attach them to multiple instances in the same availability zone, and they can both be reading and writing to a shared volume.
Well, I did not know about that, so that's interesting. Very cool.
I didn't either. I just happened to I searched it as soon as
Google it, because I would have to Google that, because yeah, that's news. I did not know they had them all. But it's only available in the improved or in the IO series.
Yeah, IO1 and 2 it looks like.
Okay, so it's not going to be in the general purpose. Got it. Okay, so
it's
there
up
you
to
go.
16 instances.
So we're butting up to lunch here. I think what are we scheduled? What time are we supposed to break for lunch? 12:30 my time. So I might have went a little long on the deck. I apologize. So so the S3 lab, this is pretty straightforward. In fact, what you're going to be doing with this lab is when you go into your AWS account provided by us through the link that you got in your email, you're essentially going to be creating a bucket. We're going to create a bucket. We're going to add an object or a file into the bucket. We're going to make that bucket public. So like I said, by default, the security says all objects are not going to be accessible by the internet, but you can change that. You can make it public. And then once it's public, I think you're going to view it, and then you're going to move it. So you're going to make another bucket. So you're going to make a bucket 2, and then you're just going to do a simple move from bucket 1 to bucket 2. And then you're going to enable versioning. So by default, versioning will not be turned on, although when you make the bucket, you can turn it on or not. And versioning is going to essentially track every time an update has been made to that file, and it will actually keep the previous versions available, so you can go backwards in time on your bucket, and you can see the changes that have been made to an object over time. So you're going to turn on and enable the versioning, and then you're just going to delete the buckets and get rid of them. So it's pretty straightforward lab. I don't think it's going to take very long. I'll go through a few of these on my own if you guys want to follow along with me, but I'll just go right up until, Melissa, we got about 10 minutes till lunch break.
Yeah, we'll have a break after your lab.
Okay, I don't want to stop people from getting lunch, so I'll just go for the next 10 minutes and then we can break.
We have scheduled for 10:35.
Okay, so we got 15 minutes, got it. Okay, so we're gonna go into S3. So if you guys haven't been in the AWS console yet, it's changing all the time. So documentation goes out of date quickly. They're always tweaking and playing with the UI and the colors and how everything looks. I will say though that the search box has gotten much better over time. I like the search box now. So when you type in S3, this is the object store service. I don't have any buckets at the moment, so we're gonna create a bucket. Now, the interesting thing with S3, and this is another exam topic with AWS, is you have to have a unique name. So if your bucket name is taken by someone else in your organization or whatever, it's going to tell you that. So I'm just going to say let's see, Brian. Version day 1. And we're going to select the region. So always make sure you know which region you're in, because if you make buckets in Oregon on US West 2 and then you log in and you go default to Virginia, you won't see your buckets. So a lot of times when people go through these labs or start playing around with AWS and experimenting, they make resources and then they say, where? I don't see it. I know I made it. Where is it? Just got to be conscious of what region you launch those resources in. So I'm going to pick US East 1, Virginia. We're going to block all public access. In the lab, they want you to enable versioning. So if you want to just turn it on right away, you're more than welcome to. We'll save you a step later. So anytime you see a green box at the top, it's going to tell you, okay, you did it, it's there. So now we have our bucket. I don't have my command line set up to this particular account, so otherwise I would show you how you can interact with your bucket through the AWS command line, but we're going to have to do it through the console because I don't have that set up. You have to essentially set up your credentials locally so it knows that you are who you say you are and you have the right rights. Okay, so we made our bucket. Oh, we didn't add any tags. I apologize. So this wants you to tag your bucket, which you can definitely do. However, for the lab, you don't really need to. It's not terribly important. Although tagging all the things in AWS is always a good strategy. Should have a tagging strategy. So we blocked access to the bucket. Like you said, some of these screenshots in this lab is going to be out of date just visually because, like I said, they make a lot of changes and updates to the UI all the time. So it's hard to keep things updated with the latest greatest. So we've already created our bucket. So we're going to add our object to a bucket. So I just made a local text file. You guys can do that too. Just make a local text document. I made one just called Hello World. It just says Hello Immersion Day, just a simple text file. So when you want to add objects to your bucket, you go in here, you go upload. Let's see, drag and drop, or we can go add files. So I'm going to go to my desktop. So it's going to give me a network S3 locate. You're going to give me a location where that bucket's going. So anytime you're interacting with the bucket, it's always going to be like S3:// and then your bucket name. This is where you can define some access controls. I could grant public access to this object right away. When you go down to the properties here, now if you're paying attention to when I was breezing through the storage class tiers, this is where you can define, do I want my object to be in standard? Do you want it to be in frequent access, one zone IA, or the very cheap Glacier options? So this is where you can define your storage class right away. If you don't define one, it's always going to automatically default to standard. You can also do server-side encryption on this bucket. I don't have any encryption keys set up in this account, but if I did, I could say, hey, I want to use an encryption key. If I had a key already set up in KMS, I could say, hey, use this key that we've already made. You can let Amazon create an S3 key for you if you don't want to go and mess with keys. You know you want this data encrypted, but you don't really want to mess with the key management. You can just leave this option and let Amazon generate a key for you, or you can make your own keys and store them in the KMS service, which you're going to learn about later on in the security deck. So just breezing down through the options, this is where you want to tag your data. So I could say like team, I'll say storage or something like that, or I'll say web. So this is our web application team is making this object, and we're going to upload. So now my text document is here in the bucket. I've uploaded, I've added an object to my S3. If you notice, these screens are not the same, which is totally fine. Like I said, UI changes are happening all the time. So the next portions is they want you to edit your settings so you can unblock the public access. They want you to make it so it's publicly accessible. I kind of want to skip towards the versioning portion of this, or maybe even moving an object. I mean, moving an object is pretty straightforward. You're going to make another bucket. You're going to copy that object from one bucket to a bucket. I don't think that's terribly exciting. I kind of want to go down to the bucket versioning. So if you want, did I enable versioning on this? Let me check. Or on this bucket. Okay, so bucket versioning is enabled. Go into the properties on my bucket. It's there. So we've already enabled versioning. I just want to kind of show you guys what versioning works. Choose a bucket that you're able, and I'll open the file. So we want to update and edit our, I'm going to update the hello world, add some additional data to it. Let's say today is Thursday. Save that. Now we're going to update, or we're going to upload this object to bucket, and it should allow us to track the versions. I'll leave all the information the same. So that succeeded. I think the UI is even different here. So we're going to click into this object. And if we go to versions, it's going to show us that there's 2 different versions. So we notice that our data size changed. So it went from 47 bytes to 97 bytes because we added that additional text. But also it's showing us the branch. So it's saying that this is the latest version, but it was the previous version is still here. So versioning is important when you have collaboration going on, or maybe you need to track for legal reasons. Enabling versioning on a bucket is going to show you the changes and kind of where all that is taking place. So I think versioning is really cool. It's something that's very specific to S3. Let's see. There's a lot of other cool things you can do with S3. However, they're not really touched on this lab. Let's see. I'll make another bucket and we'll do a copy. So, well, to keep it in Virginia, so they're staying in the same place. Enable versioning on that one too, just for fun. So what's cool is they tell you right away that bucket and objects are not public. AWS is very conscious about making sure people know what buckets are public and what buckets are not, because a lot of data breaches and a lot of bad things kind of sometimes come out of AWS from publicly accessible buckets. Permissions got changed or updated, or people created buckets that and they turned on the public access at some point, and sometimes companies make the news from data being stored in publicly accessible buckets. So AWS tries very, very hard to make sure that people know that their buckets are not publicly accessible, which is good. So I think we just go to here, we go to actions, and we can move our bucket from one bucket to another. So if you know the prefix of your bucket, so the prefix is going to be essentially your S3 colon, the name of the bucket, and then if there's any additional folders or prefixes where your object lies, you'll put in the path, but you can also browse your buckets through the menu. So I'm going to go and grab this guy. Wait, choose destination. Yep, okay. And then here's our object. So we're going to move. Oh, wait, I'm in the wrong bucket. I'm in 2. Oh, wait, we have to move from one to the other. My apologies. Getting ahead of myself. So we want our destination point to be to the second bucket. And which objects do you want to move? I only have one document in there, so move that. So now my object should have moved from bucket 1 to bucket 2. Back to S3, and there it is. And we should still be able to keep the versioning information. Oh, when you move the bucket, it loses the versioning. That's interesting. I forgot about that. So I think we're kind of butting up to lunch here.
Yes, Brian, it's just a break.
Yeah, or well, break. How long do we have the break for? Sorry.
10 minutes.
Oh, it's just 10. Oh, sorry. I thought it was a lunch break, like a longer period. Sorry, it's only 10 minute.
Yeah,
10 minutes.
we'll be back at 10:45 a.m. Pacific time, and then we'll get into security and AWS.
Okay. Well, I'm gonna let everybody go. I think we'll break now. Give everybody some time to take care of their kids, their dogs, grab a bite to eat, grab a coffee refill, whatever you need to do. And when we back on some of the stuff today, later on, we're going to cover is going to be really cool. We're going to talk really deep about networking and very deep about security. Security is really important in AWS, so I hope everybody sticks around for that. So I'll pass it along. So we're coming back at 45 after.
That's
Whatever
right.
time. Okay, great. Thank you.
Hello, everyone. It is 10:45 p.m. Pacific time, and let's go to the next stage of this workshop. To give you a quick introduction, my name is again Mohit Gadkari, and I'm this AWS Solutions Architect. And today, this session, we're going to talk about security essentials and best practices. So what we're going to discuss today is about the AWS cloud security concepts, such as security center, shared responsibility model, and of the most important concept, IAM, or identity and access management. Let's get started. Let's start deep diving into AWS security. So what are some of the percentages of cloud security what you have? Just want to start this topic on this. Well, since we are on, what I can talk in this session is about what are the positions people have and what does AWS has to offer. And AWS, what we say is cloud security is job zero. So what that means is that all our AWS customers benefit from a data center and network architecture built to satisfy the requirements of the most sensitive security organizations. I just want to highlight in this slide that we have at AWS world-class security and compliance teams watching your back. And one of the key advantage here you see is that every customer benefits from the tough scrutiny of other AWS customers, and this helps expanding the ecosystem of AWS security. As you can see, we have a broad accreditations and certifications, and this slide just highlights few of them. If you are in the healthcare sector in the US, HIPAA is important to you, and we are HIPAA certified. And also, if you are in the payments industry or financial domain, PCI DSS is an important compliance certificate you need to get. And AWS, I can say happily that we are our infrastructure satisfy the PCI DSS compliance requirements. I put this link, and you all have the slide deck. You can definitely check out the link here, which tells you the complete list of all our compliance programs. Let's talk about what's the shared responsibility model in the AWS world. There's a shared responsibility to accomplish security and compliance objectives in AWS Cloud. There are some elements that AWS takes responsibility for and others that customers must address. The outcome of the collaborative approach we have seen is positive results for customers around the world. And I will be covering more about this shared responsibility model as we go in the slides, like what does AWS responsible for and what is the customer responsible for. Let's start diving deep more into it. So we at AWS look after security of the cloud. So what it means that if you check this slide, like the AWS regions and the AZs, what was explained earlier in the session, the security of those physical locations, we take care of it, also of all our foundational services. You as a customer, when you deploy your applications on our AWS platform, you're responsible for taking security of your own applications. Yes, we provide you tools, we provide you guidelines, how can you take care of it, but we stress that it's a shared responsibility model. As you can see, you as a customer can meet your own security objectives. You can define your own certifications, and we help you get those. And it's a teamwork, and we always are here for you to help you achieve your compliance objectives. So what are the AWS responsibilities? Let's talk a little bit more about it. So as you see from this slide, we have experience in building large-scale data centers for many years. All our access is logged and reviewed. we follow SOD, or separation of duties, where employees with physical access do not have logical privileges. What that means is that the employees working in a data centers do not have idea about whose workload is in a data center. Also, even I'm an AWS employee, I do not know the physical address of any of our data centers, nor do I have access to it. Zoning more on the AWS responsibilities. So we take care of the hypervisor, which where your host is. We take care of the operating system. And you own the system completely. We as AWS admins cannot log in, as you can generate your own key pairs, and we'll be talking more about key pairs as I move over the slides. We do not have access to it. Also, just want to stress one point, like on network security, we do not allow IP spoofing at a host OS level. So we really want to make sure that your instances or EC2s, as we discussed earlier, are secure to the maximum. Again, just want to stress one point about continuous availability. All our EZs are always on mode. So we do not have a separate disaster recovery data center, and they all manage the same standards. One thing I can say is that we have like dashboards, which you can see links here, which tells you if there's any service being affected, we communicate to customers via email or this dashboard, as you have seen here. We always keep us services pretty transparent. Just zoning more about the disk and storage. So one thing I want to highlight about storage is that we go through these rigorous techniques like DoD or NIST when we are decommissioning any of these storage devices what we are using. And just want to say that ultimately we do destroy those devices, we do not reuse them. So I want to just say, like, if you see here, these are some of the responsibility model we discussed. Just want to like quickly highlight where does, if you go, you see in this slide, we have the one in highlighted in blue is the customer responsibility, and the one highlighted in orange is the responsibility of AWS. So as you can see, as we together, we can achieve the security goals, what we strive for. Let's talk about identity and access management and what it means. So IAM, or Identity Access Management, allows you as a user to implement a comprehensive access control on AWS resources. IAM gives you the ability to authenticate, authorize, and log all access. Authenticate includes regular credentials with strong authentication for your privileged users or everybody, as well authenticate on all other AWS accounts or even trust other identity providers. Authorize with granularity, who can do what. Therefore, we always recommend you implement least privilege and segregation of duties. And finally, log every allow and deny in CloudTree as one of our managed service for troubleshooting or auditing purpose. Basically, when you think about access control with AWS resources, think of IAM every single time. Just want to say this is what we call the 3 A's with AWS, and then so is authentication, authorization, and auditing. And I will be going over these services a bit in depth as we go through in slides, but we authenticate with your usernames, with your IAM username password. Always recommend to do a MFA or multi-factor authentication. You authorize with defined IAM policies. So as I said earlier, you can define who can do what. And finally, but the most important, always log every single action. So the key takeaway here is, if you see from the slides, that we operate on these 3 different levels, right? Like operating systems are currently outside the scope of AWS IAM. As you can see here, like Amazon Web Services have different AWS interaction identities. let's talk about what is this AWS principles is. So when you create your account, you have the root permission, or you have like a root ID, what we call. This account has maximum permission, so we always recommend that when you start developing or building your applications, you create IAM users, groups, and rows, which hereby limits the access to specific services, and then you can control if they want to use the console or the API. For further, I recommend is that you always try to use temporary security credentials to access specific services. This goes back to what I said earlier. You have least privileged access, and you always give role-based access control. You have different ways. We let you know how how do we know who you say who you are? Well, either you use our console and with MFA, or you use your API access, or you can also use a security token. So there are different options we give you, and you choose what's most convenient for you. For example, when you're setting up your account, you can use a console, set up all your billing alerts. But say you're developing an application which requires a specific resource, you can use a CLI. For doing any automation, you can use a CLI or API access and get the right credentials on a temporary basis to do what you need to. As you can see here, the account owner or the root owner, as I said earlier, can almost do anything. They have the most power. So we always say that you have an MFA for this account, and do not try to use it unless it's absolutely necessary, and do all your development, your application workflow using our IAM policies. This slide highlights the hierarchy of privileges. So as you can see here, again, the root owner has the most privilege, and they have unrestricted access. The IAM user, as we said earlier, has restricted access. You only allow, in this case, S3, which are explained, these are object storage, as explained by Brian earlier, just allows, in this case, only to access this resource. Again, if you now further narrowing down the access, say if you give them temporary security credentials, now they can only access a particular bucket in S3 and not entire S3. So this just tells you how you can limit your access, and then how you can limit bad actors from accessing your AWS ecosystem. As you can see here in this slide, you can say you have you can have an account, and then you create different groups. So you have an admin group, say in this case, Bob and Susan are the group admins. They have more AWS accesses. Then you say it's a typical software engineering team. You have a group of developers. They need certain AWS access service. You create a group, an IAM group, and assign policies to that IAM group, and add these users to that particular group. So now you say you have a QA department, and they need certain other services. So instead of like adding them to the same developer group, you can segregate and have a separate test group. There might be a use case where your test engineers might need a different AWS services than the developers, and vice versa. And always, I stress, you always have multi-factor authentication set up. So as you can see here, what is trying to this slide tells that you can access now, a little bit going over how to access your application operating systems. Say if you are on-prem, you have your application running on-prem, and also you have your new applications running on AWS. How do they communicate with each other? So say your EC2 instance can access your on-premise directory via VPN. We also create federation via one-way trust or Active Directory federation services. And we leverage AWS directory services for Samba-based directory services. So what's AWS directory service? So it lets you run your Microsoft Active Directory AD as a managed service. The advantage here is that if you're already using the Microsoft AD, your users do not have to create one more username and password to log into our console. You can simply leverage the services what we have given here, and have a seamless connection for your users to access our resources. Again, that saves you creating one more password leaks, and again reduces the attack on your AWS environment. We talked about IAM. Let's talk about encryption and what it means in the AWS world. So how do we currently encrypt data? There are different ways we can encrypt data, and I'm just going to show you some of and highlights what encryption means in AWS. So we provide ability to our customers to encrypt their data as it sits and it flows in and out of our environment. So we call it encryption in transit and encryption at rest. We have different services which help you achieve this goal. And some of our key services are KMS, or Key Management Service, which I will be explaining. Also, we have Cloud HSM. We encrypt our EBS volumes. Also, if you have your traffic flowing in and out, we provide ELB SSL offloading, to name a few. If you're using a S3 service and you upload objects or say files, we offer S3 object encryption. If you're not encrypting data right now, either in transit or rest, maybe this will help you just think about how it's important to encrypt your data, and this again falls in the realm of shared responsibility model, what I discussed earlier. So let's talk about encryption at rest. I'm going to start with database encryption. So as you see, we have different AWS managed services as database engines. So if you look at this slide, you see we offer TDE encryption for MySQL or for Oracle, and also we have a KMS or Key Management Service. Even our data warehouse service, Redshift, we encrypt it. We discussed a little bit earlier about this. S3, our object storage service, we offer server-side encryption. We offer customer product keys encryption, or also if you want to encrypt your own your objects with your own keys, we even offer that. Going one step forward and listening to our customers, if you have to encrypt your volumes, your stored volumes, you can take leverage of our AWS marketplace and partner where you have solutions which you can use. Say you're comfortable using a different solution and it's available in our marketplace, you can use it. We never impose on you, you have to use our services to encrypt your data, because we know security is a shared goal, security achievement. Talk about this service. It's called the AWS Certificate Manager. So what it does, it helps you easy to manage, deploy, and renew your SSL or TLS certificates on AWS platforms. Once you are able to deploy this certificate, you can use it with other AWS services like load balancing, or even a CloudFront distribution, which is CDN. AWS handles the key pair and the CSR generation. We handle the domain validation, and this is available through our console, CLI, or API. Let's talk about our key management service. AWS Key Management or KMS is a managed service that makes it easy for you as a customer to create and control the encryption keys used to encrypt your data and use hardware security models to protect security with several other AWS services. To help you protect your data and store these services, this AWS Key Management Service is also integrated with CloudTrail, which I explained earlier, so where you can log all the key usage to meet your regulatory and compliance needs. This is integrated with AWS SDKs and other AWS service. So we make it easy for you to use this service in conjunction with other services to achieve your encryption goals, as you can see from the slides. Let's talk about Cloud HSM. So what is this? It's a cloud-based hardware security module, or HSM, that enables you as a customer to easily generate and use your own encryption keys on AWS Cloud. With Cloud HSM, you can manage your own encryption keys using FIPS 142 Level 3 validation HSMs. The most important part about this service is that you as a customer control keys stored on these modules. AWS manages and monitors this appliance but does not have access to the keys. In fact, if you lose access to your credentials, AWS can't help you recover your key material. You can recover from your own backup if you have a backup with the required credentials. And so this again aligns with the separation of duties as I explained earlier. The cloud HSM appliances are inside your VPC, and we'll be covering about VPC with my fellow SA Cheng in the next lecture. So you can use familiar network security groups and access control policies to limit this access. Cloud HSM customers are using it to protect this master keys for database encryption, such as Oracle or MySQL Server. Well, you can always find more about Cloud HSM at a link which we can send. It's just awsamazon.com/cloud HSM. Now let's pivot a little bit on configuration management, as security and compliance always goes hand in hand. I'd like to introduce to our service Amazon Inspector. So Inspector is an automated security assessment service to help improve the security and compliance of applications deployed on AWS. As we explained earlier, 90% of our backlog comes from customer feedback. That's one of the reasons we build out WAF or AWS WAF, which means AWS Web Application Firewall. WAF was initially a CDN offering, but now it integrates with ELB or Elastic Load Balancing as well. WAF helps you protect websites and applications against attacks that causes data breaches and downtime. General WAF use cases, you can say, is protect from SQL injection, cross-site scripting. It also prevents website scraping, crawlers, and bots. WAF also helps mitigating DDoS or HTTPS floods. We have seen that from Gartner report that 25 to 30% of WAF purchase was mainly to achieve PCI compliance. I briefly touched about CloudTrail earlier. I'm going to use this slide to deep dive more about it. So if I have to explain CloudTrail, I say it tells me who made the API call, when was the API call made, what was the API call, which resources were acted upon in the API call, and where was the API call made from and made to. This gives you a pretty robust understanding about what API calls were made on your AWS account. Going one step further, we always recommend to store these logs in a durable location like an S3 bucket. One of the best practice is that you say you have multiple AWS accounts, say one for your development and testing and one for production. We recommend to have a separate account just for logging, where you can deploy all your CloudTrail logs to a centralized logging bucket, enabling log file integrity, which means that your log files are never tampered. That's one of the best practice I can recommend. Also, you can consume your logs, as I said, via console, CLI, and if you are already using third-party tools like Sumo Logic or Alert Logic, Datadog, etc., you can integrate CloudTrail logs with those tools and get the right level of automation what you desire to achieve your security and compliance goals. One of the important AWS services is a whole AWS CloudWatch and its suite. You can use Amazon CloudWatch to gain system-wide visibility into resource utilization, application performance, and operational health. You can use these insights to react and keep your applications running smoothly. CloudWatch has different services in it. We have CloudWatch logs and CloudWatch in general. So as where you can get your metrics. As you can see here, CloudWatch tells you your CPU, monitor, and memory usage. And at the same time, you can create alarms and automation to scale your EC2s based on any anomaly you see. One of the using CloudWatch dashboards, you can see the operational status of your applications and identify issues. You can use these tools in your DevOps pipelines and have continuous automation and continuous monitoring of your applications. Let's talk about VPC flow logs. Yep, you're right. There's no agents. You just turn it on. That's it. And you can enable it on per VPC, which we will be talking in more in the next slide. So what does this VPC flow logs do? All your network traffic data is logged to CloudWatch logs, so you get durable storage. But you also have analysis features such as filter queries and metric creation. And you can create alarm on those metrics. These are collected, processed, and stored in a 10-minute capture windows into CloudWatch logs. Now in the next slide, and now I'm going to show you how to decipher this CloudWatch logs. As you can see, it's coming up right now. So here you see you have your AWS account, you know your interface, your source IPs. We also tell your protocol, the packets, and we let you know if that packet was accepted or rejected. And we give you both start and end times to name a few. So using this powerful tool, you get an idea about your network traffic. Or, if you want to roll your own real-time network dashboard, you can use an Amazon Elasticsearch service. It's based on a CloudWatch log subscription filter that tees flow log data into a Kinesis stream. Kinesis is a real-time service which helps you get insights on your data in real time, and Stream Reader that takes this data into Elasticsearch. This is one of our new offerings. It's called Service Catalog. So what it is? So it lets you create, for you an organization to create and manage catalogs of IT services that are approved for use on AWS. What is the use case of this? If you think about it, say you are starting up you're building a new platform on it, using a platform to build a new application on AWS. You're just getting started up and you wanted to have control over what resources are provisioned, and you want to make sure that you do not over provision some of the resources. If you know exactly what are you going to provision, you can use a service catalog where it will create a catalog of resources, and your users can just launch this via a self-service portal. One of the other advantage of this is that it also controls user access to applications or resources on a per compliance needs. So A, it achieves your security and compliance goals, and B, it also helps you in achieving your cost control goals. So it's like a win-win situation. AWS Config. So AWS Config is a fully managed service that provides you within an AWS resource inventory, configuration history, and configuration change notifications to enable security and governance. With AWS Config, you can discover existing AWS resources and export a complete inventory of your AWS resources with all configuration details, and determine how a resource was configured at any point in time. These capabilities enable compliance, auditing, security analysis, resource changing tracking, and troubleshooting. So I can explain you one use case. We discussed about AMI or Army in one of the earlier sessions. So you, as a customer, you create your armies and you're deploying your EC2 instances using an army, but you have defined certain rules on if they pass those rules, this army is compliant. And say for some reason you generate a army which is non-compliant. So using AWS config and some of our other automation services like Lambda and Event Bridges, you can create an automation flow where if AWS config detects a army which is unapproved from your compliance perspective, and an EC2 instance is running with that army, you can isolate that instance or stop it, automatically. That is the power I can say of AWS config. This ties into the use cases is about the security analysis, the audit compliance, your change management, troubleshooting, and discovery. As I explained earlier about config and config rules, so this is what it means. A config rule represents a desired configuration for a resource and is evaluated against configuration changes on the relevant resources. The results of evaluating a rule against configuration are always available on a dashboard. So using this config rules, you can access the overall compliance and risk status of your application. It also helps you to know where is a drift out of compliance within a rule. So coming back to the example I gave about this armies, you can see the results about those rules and its actions in this config service dashboard, which helps you know what has changed from normal. As you can see, you move from record, normalize, and then you go here. Next, I want to talk about additional best practices and how it can be helpful. At AWS, we have 5 pillars of the well-architected review. It's cost optimization, performance, security, high availability, and operational resiliency. Whenever we build our applications, we recommend our customers to follow these 5 pillars to get the best advantages of the whole AWS cloud ecosystem. And there are reasons. These are the reasons that most of our customers use AWS. As you can see, security is one of our top pillar. Whenever we analyze a new workload a customer brings to us, we analyze them against these 5 pillars, and I myself have been doing the security pillar well-architected review with them. By doing this kind of reviews, what we have seen that we have helped customers in defining their access to the applications, defining their encrypting strategies, defining who is authorized, and defining how can we also help them continuously monitor and automate the security best practices. Again, along with security, as I tied to my earlier example, cost optimization. So when I talked about example about how you can tie the service catalog, you get security and least access to the applications, but also you're optimizing the cost, which is the cost pillar, where only limited resources are being developed and used. At the same time, there is no over provisioning of resources. We do this in the beginning analyze the workload, but then also we give you as a customer a managed service to make you self-sufficient. And that's the system I want to talk about is AWS Trusted Advisor. AWS Trusted Advisor provides recommendations that helps you follow AWS best practices. Trusted Advisor evaluates your account by using checks. This checks identifies ways to optimize your AWS infrastructure, improve security, performance, reduce costs, and monitor service quotas. What we have seen that since the introduction of AWS Trusted Advisor a few years ago, it has given over 1 million recommendations. And what we have seen is that from a customer feedback, we were able to recommend customer savings worth over $30 million. And that's a huge saving, as you can see from cost perspective. I'm also going to use this opportunity to introduce some of our newer services. We had a service called Amazon Macy. Amazon Macy recognizes sensitive data such as personally identifiable information (PII) or intellectual property and provides customers with dashboards and alerts that give them visibility and how this data is being processed, accessed, or moved. The fully managed service continuously monitors data access activity for anomalies and generates detailed alerts when it detects risk of unauthorized access or inadvertent data leaks. Amazon Macy uses machine learning to automatically classify and provide visibility to understand where important business data exists across an AWS environment. Some of the features include, but not limited to, automated content classification, data access, and context about whether a user account group or group of user accounts are exhibiting unusual behavior. Amazon Macy then starts identifying and protecting the data that attackers are likely to target. It learns automatically jargon, internal project names, and estimates business value for each object and file across a company's network within S3. For large organizations, this can be 100 or millions of documents. So some of the use cases I can think about for Macy, if you're from the financial services and you have a lot of PII information, this is one of a very useful service which I would really recommend to take advantage of. I've been working with customers in financial domain and they have been enabling Macy, is really helping them to see if there has been any anomaly or attacks on their intellectual property data. This is what, and then we also give you like a robust dashboard which tells you the risk and are you what is their risk tolerance right now. As I said earlier, we never really force you to only work with our services. If you are comfortable with some of the existing security partners which we have, we always recommend you to work with them, and together we help you achieve your security goals. Our security partners offers hundreds of industry-leading products that are equivalent, identical to and integrate with existing controls in your on-premise environments. These products complement the AWS services for you to deploy a comprehensive security architecture and a more seamless experience across your cloud on-premise environments. As you can see here, we have defined like 5 pillars, of our security partners, and let's quickly deep dive into each one of them. We have infrastructure security. It is designed to identify and protect your applications and data from cyber attacks and other advanced threat vectors. So for Barracuda, Fortinet, or Palo Alto networks as an example. Second, logging and monitoring. You maintain visibility and audibility of activity in your application infrastructure while providing policy-driven alerting and reporting. So some tools we talked about like Sumo Logic or Alert Logic or Splunk, if you're comfortable with, you can use it in conjunction with our logging and monitoring services. Identity and access control. It helps you define and manage access policies to enforce business governance, including user authentication, SSO, and enforcement. Very familiar with OneLogin or Okta, which is some of the popular identity and access control services, and they work well within the AWS ecosystem. In fact, one of my previous organizations before I joined AWS, we used to use Okta to sign in to AWS. Configuration and vulnerability analysis. It helps you inspect your application deployments for security risks and vulnerabilities while providing priorities and advice to assist with for remediation. We're familiar with Tenable, for example, or Trend Micro, which gives you this analysis, and this helps you achieving your SOC 2 compliance. Data protection. It helps you assisting with safeguarding your data from unauthorized disclosure and modification. through encryption, key management, and policy-driven controls. Now we talked about some of the security partners. I just want to take a couple of minutes to talk about how can you harden security on your host. Say you're deploying your EC2 instance using an army. Now, once you have an army, the way you can harden it by doing a couple of things, right? You can have to always make sure you encrypt your armies. You create the life cycle of launching your instance with an IAM role. So what it means by this, you restrict access wherever possible. When you launch an EC2 instance, yes, you can use your key pairs to go in the beginning, but to access non-prod environments, but we recommend you to use other tools like SSM or Security Service Manager or Systems Manager to access your instances. We recommend you use Bastion host to access your EC2 instances for even more security. What we want to say here is that we want you to make sure that especially in production environments, you do not have EC2 key pairs lying around. Also wanted to make sure that you always create a reusable army, so you can create an AMI or army from an EC2 instance, secure it, and then copy it in a different region if you have a multi-region deployment. And just some of the topics you can do, while you are enforcing security on your host. Your security posture is determined by the whole of mechanisms you employ, and there is never enough. You can always secure it more. We do provide tools and guidelines to always make sure that you are attaining your security goals. So this is just a review. As you can see, we start with physical security with our compliance and third-party attestations. We talked about system security. You can use IAM roles to access your applications and not credentials if you can, or if you're using your credentials, make sure they are temporary credentials. We talked about data security, like how you can have encryption at rest, how you can have user authentication and logical access to controls. We're covering networks in the next section, but on a high level, you can use these tools to make sure that you get you're securing your network too of your data. So it all works in conjunction, which will help you achieve your goal. So I want to introduce a security center and what it is and how it can be helpful. We dedicate an entire section of our website to the security and compliance center to communicate with our customers, providing things like white papers, security best practices, security bulletins. We also take requests for customer penetration testing. We're definitely sending you have this deck, and you can feel free to check this out. We keep updating our web page, so you might see a different UI, but rest assured we are always updating with the best practices. These are some of the other security resources what we discussed. You can take a look, and also I recommend you to subscribe to our blogs. It's a great way to stay up to date on AWS security and compliance, and it also talks about some of the new services what we release. And one of them is Security Hub, which actually gives you the overall health of your security infrastructure, security of your infrastructure. All these services, what I was mentioning earlier, you can have like a one-stop shop where you can see the snapshot of your security using Security Hub. These are like just all our compliance assurance programs, as we said earlier, just to give you like a quick summary of where do we stand and how do we help you. Since we are global, we also support the compliance programs of those particular countries. With that, I would like to end this presentation. Thank you again for giving me the time. And if you have any questions, please post on chat. I'll be happy to answer them. Thank you again.
Good morning, everyone. Wow, I know it's a lot of information, and we have been through the AWS introduction this morning, and also we have talked about the storage and a lot of information in terms of the security. So we have 1 more hours, and in the next 2 hours, we will cover the networking. So it's going to be shorter than the previous sessions. Hopefully we can spend like 30 minutes, go through some fundamental definition and how the AWS networking works. And then we will go into a lab for another 30 minutes. So in 1 hour, we will go through some of the basic networking, and then we will do a network lab. And that's it for everything today. I know it's a lot of information, and bear with me. That's the last 1 hour of the session, and we don't have a break between the security and the networking, and we will just take this 1 hour and go through everything, and then we will be done for today. All right, cool. Thank you. So let me get started with networking. My name is Chen Lun. I'm a solutions architect with AWS. So let's go into our agenda today for the networking. So basically, we have been through, you guys already created the EC2 instance if you are on the lab, and then you already created S3 buckets. And we talk about the security. So all those things, it just show you how easy it is for AWS to start working. You don't need to know that what's going on behind the scene. But fundamentally, the cloud is like your data center, but it's like virtually in the cloud. And then you do have the control of everything how you want to define your network. So this is the fundamental networking behind the scene in AWS. We call it VPC, Virtual Private Cloud, and we are going to go through some of the foundation and components of the VPC, and we want to talk about how you can secure your VPC in two different ways, from the basic ways, and also we want to talk about how can you connect, either it's between your VPC, your networks, or from your on-premises or your core locations to the AWS data center. And then on the end, we want to talk to how can you distribute the traffic to your application so you can make it highly available. And then we will do the lab, okay? So VPC, I have talking about the VPC. Well, what it is VPC? So VPC is like your data center in the cloud. We call it virtual private cloud. And it's a logical isolated section. So the AWS is a shared resource services. So in the how do you get your private cloud is you define a logical container for your cloud for your inside your account, and then that's where you can spin up your resources like EC2 we mentioned earlier, or some of the database services, or uh, and so on in the AWS. So this is similar to your data center. How you create your data center, you go into the data center and you set up your equipment, and then you start to set up your network. You will define some of the IP address for your network range, and then you will create the subnets, and you start to segment your network for security purpose. And then you have some topology of your choice, and then you define your route rules, and then you secure your data center. So it's very similar. You can take all your knowledge about the network and apply that into the AWS VPCs. So everything is very familiar with your the traditional data center if you already work on that. So here I want to show you a very, very high level about what VPC is and how does that define your network. So in the AWS, if you see the outside box, there is a white box, which is just logically is AWS cloud. And then when you create a VPC, what are you going to do is you will give a name of the VPC, and then you give a IP address range. We call it CIDR. So it's a private IP address range. So you say, this is a range that I want to do. I want to create my VPC, and then within that you will create the networks like subnets. So there are some resources that run inside your VPC, like EC2 we see earlier, and I think Lens introduced Lambda as well, and there are some database service and so on. So there are a bunch of the services that will run within your boundary of your VPC, and at the same time, there are some services like S3, we already saw that, and then or like DynamoDB, those are managed services with the external URL as the entry point and endpoint. Like when you see that when Lens troubleshoots his web page, we see that S3, there's a URL for the S3. So basically that's not part of your VPC. So you're going to access either the API for the S3 or the object in the S3 through the public network. So by default, but we will talk about the options, how you can connect within and outside of your VPC. All right, so now you have your VPC created. We want to talk about how you can manage your VPC. So VPC, now you have the VPC defined. Remember earlier that Lens mentioned that we have multiple regions, and within regions, what do we have? We have those availability zone. And within each of the availability zone, we have like one or more data centers within that. So what you want to do with subnet is you can create the subnet which is within the IP address range you define for your VPC. Then you create the subnet on each of the availability zone. What does this achieve for you is when you create your subnet in the different AZ, we call it AZ, availability zones, you have the ability to make your application more highly redundant, highly available. And at the same time, when you create multiple subnets, that allow you to define your network topology, how you want to segregate your network, create different segments for your network. So this is where you start to create a subnet within each of the availability zone that's available for you, and you can choose create more subnet in one zone, or you can create multiple subnet in different zones. So it's all up to your choices. And once you have a network or your subnet defined, naturally you want to have your traffic flow between your subnet, right? So here is when you create your network, you don't have to worry about how to route the traffic, because all the subnet by default will be able to reach each other because behind the scene we have a router, a cloud router work behind the scene. But you do have the control of how you want the traffic to be routed. And in a very high level, each of the subnet you can attach a route table to it, and you can attach a route table to multiple subnet as well. So in the route table, you can define how you want to route your traffic. So here it comes interesting. Your traffic is not going to just between your subnets. You would like to go out to the internet, or you could want to go to your corporate locations. So there are different ways. We would talk about this later in the session today. I mean, in the next few slides. So there are different ways. You want to go out to the internet, you want to go to your corp, and you want to access the services we mentioned earlier, like S3 or DynamoDB with a more private way, or you can access between your VPC. So those are the options that you can use for your route table. That will you have 100% control about how you want to route your traffic. And you might have heard about public subnet or private subnet a lot. So I want to take a quick explanation about what is a public subnet. So when you create a bunch of the subnet by default, they are private. You cannot go anywhere. But if you need to go out to the internet, you can create something called Internet Gateway. And then whenever there is a subnet, for the route table attached to subnet has a route going to the Internet Gateway, then that means that particular public subnet instance within that subnet will be able to have a public IP address attached to it and then go out to the internet. So when this happens, and we will call it public subnet. So later on in our lab, we will show you how those things work and what is a public subnet and what is a private subnet. So we mentioned the Internet Gateway now. So you have your VPC defined, you have couple subnet created. Now you probably don't need to go to the internet, then you are fine. But if there's any reason, for example, you need to download the patches or something like that, or you need to allow the public access to your network, then you do need something called internet gateway. You do need to go to the internet, and we provide a service called internet gateway. And what is internet gateway? Basically, say, think about in the data center, if you have your ISP hand over a line to you, and pretty much similar to that. So we can, in AWS, you can create something called internet gateway, and which is horizontally scalable and is highly available. So basically, it will scale as your traffic goes down. So, and you also don't need to worry about redundancy because it's building with the redundancy. It's not a single point of fail for you as well. So when you need to go to the internet, you will create the internet gateway in the AWS, and then you can reference the internet gateway in your route table and attach that to your subnet. Then you will be able to go to the internet in this case. All right, so what I mentioned earlier, the internet gateway, and then you got IP address. Actually, it's a routable public IP address, and you have the IP address attached to your instance, right? So like ISP, a lot of times they will give you a bunch of the IP address, which is owned by the ISP, but they let you use those IP address. So you can keep reusing those IP address and that's a more static IP for you. So you can, depends on your usage, they won't change. So similarly, if you do, in the AWS, we have something called elastic IP address. That means when you allocate a IP address, a public IPv4, a routable address, then that address belongs to you at the time of your allocation. So you can keep reusing that, and you can attach to a single instance, and then you can move that to a different instance later. So when you have the need for a static IP address, we do have a service called elastic IP address for you. Okay, so then on the next situation is not all the instance you have, and you really don't want to have a public access to your instance. So, but what if you still need to have internet access for the instance within your subnet? What you can do here is a NAT gateway. So it's similar to maybe your corporate location or even your home. You have a router that goes to your home, right? And then you really don't have a bunch of the IP address, but you have a lot of devices within your home or your corporate network. So what do you do to utilize that single entry point from the internet is you use a NAT. So in AWS, we have something called NAT gateway. It's very similar to the internet gateway. That's scalable, it's highly reliable. So basically what you did is you can create a NAT gateway and then point your route to the NAT gateway, and you will be able to go through that NAT gateway and go to the internet gateway and go out to the internet. And so this is for outbound access only. So whenever you have the need for any of your network that require access to the internet outbound only, then you can utilize the NAT gateway for this purpose. So earlier we mentioned the private network, private subnet for the public subnet and private subnet. So for the private subnet, and you can point your, say, a route to the NAT gateway as well. So in this case, although they have internet access, but it's outbound only. So those are still the private subnet it's not a public subnet. Okay. So until this point, we have a VPC created and we have multiple subnet within, and then we are able to go out to the internet and then through a different way, either through the internet gateway or through the NAT gateway. So it's important right now you have to expose to the internet. You really want to secure. Not only you want to secure with inside and outside the internet, you also a lot of time you want to make sure your application is talking to the right group of the server only. So this is where there are different ways we can secure our network within the AWS. So I'm going to introduce two ways of doing this quickly because they come with all the instances and they come with all the subnets. So you have two ways that you can secure your the network traffic. The first one I want to talk about work on the instance level. What do I mean the instance? So basically when you create a device, let's say EC2, and you create a database, or you create a load balancer. We'll talk about load balancer later. And so when you create some network related services within the AWS VPC, it will have you can attach a security group to the instance. So it's a single instance level of the protection. And what does that mean is this security group work on a single instance, and it's like a virtual firewall to your instance. And very important here, it's a stateful firewall. So basically it keeps the session information about your packets. So you don't have to specifically say outbound if it's a reply traffic to the outside request. So this is an instance level virtual stateful firewall attached to your instance. So there are different ways you can use the security group, but the very basic way is it has a deny all by default. So if you didn't specify any rule, by default, it's actually block all the traffic, so you will not be able to access this. Then, so on the other hand, if you want to allow the traffic come into your particular instance, you need to state that, okay, I want to allow the resource, and the resource can be IP address and can be another security group, or can be this particular the security group that attached to itself. So it's up to you how you want to configure your security group that allow traffic to come in and out. So on the other hand, if you want to control the traffic, not just on the instance level, but you want to apply it to the entire subnet, you can do something called NACL and network access control list. So in the network access control list this is associated with the subnet, all right? So with your subnets that you can apply a network access control list to your subnet. So this apply to the subnet wide. It's not into any particular instance within that subnet. So what's different between this network access control list and the security group? The very basic, the first one is we just mentioned, network access list attached to the entire subnet. And for the security group, it's attached to only single instance. That's the first difference. And then second thing is this is a stateless access control list. So what that means is it inspects every single packet. It doesn't have the information about the session of or the traffic. So it will just blindly inspect every traffic go in and out of the network. And then third, you can allow and deny to the access control list. So earlier the security group, only thing you can define is allow. Otherwise it's deny everything. But here you actually can specify which one is allow rule, which one is deny rule. And then on the other hand, so there is a list of on your access control list, you can have multiple rules. So they go from like lower number to higher number. They will inspect one line by one line until if see a match. So if there's no match, there's another default rule on the end. So based on the default rule that you define, the traffic will be allowed or denied on the end. Okay. So this is the two ways that you can protect your network from subnet level and instance level on the AWS VPC. All right, so now you have your VPC protected, and there's a lot of connectivity options you need. Say for example, you need to connect to the S3 bucket, or you need to connect to your corp network, or between your VPC, you have different a need to connect to different VPC. So I want to quickly go over some of the options, how you can make the connection to the different network components and different locations. So first thing is the VPC endpoint. Remember earlier we talked about S3 and DynamoDB and some other services. They are API based. When you using those services, they actually gave you a API endpoint, which is through the internet. So you have two options here. Either you go out to the internet and then you can access those. But if you don't want to go out to the internet and you want to keep it totally private, we have an option called VPC endpoint. Basically, it's what you did is you create an endpoint that's within your VPC, but it's point to the services like S3 DynamoDB, or here we have key management services, then when you define this, your instance or anything that require access to those resources will go through this endpoint. And at this point of time, either they are a managed service or another service on another VPC, they go through the private network of the AWS. Lens show you a slide which has all the interconnect network, which is the network this service is going through. So it's totally within the AWS only. You will never travel out to the internet in order to access service. So if you have the need that require totally private connection for those traffic, or you really don't need the internet for your network, and you don't even want the internet gateway on your VPC, then those are the options for you. And so same thing, similar to internet gateway or net gateway, those are scalable, highly available services. So this is the first option, that you can access the resource on other VPC or manage the AWS service privately through the VPC endpoints. All right. The next thing is, if you have, as your network grow, right, and you will have multiple VPCs, you probably have VPC for different purpose, different product, or different environment. It's up to you how you want to define your VPC. And if there is a need to access the resource, say maybe you have a VPC that hosts all the monitoring or the shared resource. So how can you communicate between those VPCs? The first option is VPC peering. And as the name suggests, it's just peer your VPCs. So when you create the VPC peering, then you can point the route table that we mentioned earlier to the VPC peering for the particular address range that need to go to a different VPC through the VPC peering. So there are two things important here that bear in mind is, when you use VPC peering, it's not transitive routing. So what does that mean is, if you have VPC A, B, C, and you have a peering between A and B, and you have another peering between B and C, that doesn't mean you can route your traffic from A to C through the B. If you need to connect from A to C, you will create another peering. So basically, you're creating a mesh network in these cases. And another thing is, this is important as well, that when you plan for your VPC and your subnet, you want to make sure they use the address range which is not overlap. Otherwise, you will not be able to route your traffic through those peerings. All right, and the next thing, so as you know, if you have a simple network, I think VPC peering is more than enough. And also that's actually the only way we can do this back a few years back. But we introduced a new way to connect between the VPC called transit gateway. So what does this mean is, if you can create a transit gateway, and this function like a hub and spoke, so you can connect multiple VPCs to this transit gateway, and then you don't have to route everything through everything. You can have a routing domain within your transit gateway, so only certain traffic is allowed to go through the certain way. So this will make if you have a lot of different VPCs, and this will make your life much easier to connect your VPC in between. So transit gateway will be much easier for you to manage your routing need. So now you have the connection between your resources in AWS. So what is our options to connect to outside of the AWS? So the first thing is, say you have a corp network, or you have a data center that you want to connect your current on-premises data center to the AWS cloud. And first thing, the most easy and you can get it up and running quickly is virtual private network. So this is just like, right now you work from home, you probably connect to a VPN. So this is going to be a site-to-site VPN from your endpoints, say your data center or corporate location, to the AWS. And then AWS will have a redundant IPsec. The requirement is you have to have at least two, you will have two connections. So you have two redundant IPsec tunnel that connect to the AWS. So this is the first option, that to have you connect your outside resource to AWS. and you can use BGP or the static routing for the AWS virtual private network. And another option is, say, VPN, you still go through the internet, right? So you still rely on your ISP. So if you want to have more consistent network performance, and you can choose another service called AWS Direct Connect. So AWS Direct Connect is we work with our partners. So we have more than 90 direct connection locations across the global. So what you can do is you can work with the partner, and then you create a dedicated line from your corp locations, and then you can connect to our AWS Direct Connect locations. And then once you have this connection, you are into the AWS network, and through a connection is totally belong to you, and you are not sharing that with anybody else. So this is another option called AWS Direct Connect for you to connect your outside resources to AWS. So put everything together here. I want to, put, you have the in between VPC connection, you have outside connection, and one of the product that we introduced earlier is the transit gateway. So with the transit gateway, you can actually connect everything together, like the direct connect, the VPN, the VPC, and between your VPC. So that gives you a very flexible way to control your connection in between multiple resources. All right, so congratulations. Now you have your application up and running, and you are going to host your traffic to the customer. So, and you follow the best practice, you create your resource in different availability zone. Now it's all good. How can, so as a customer facing application, how can you make sure your customer has the best experience? Is you can distribute your traffic to the resources that your hard work you created through your hard work in the multiple location. So here you can use elastic load balancing. So like if you're familiar with the load balancer like F5, or maybe you use HA proxy or Nginx to load balancing yours, this is very similar to that. So basically in the AWS, this is similar, like all the services we introduced today. It's scalable, it's highly available. So elastic load balancing work as a load balancer that distribute traffic through a different, say, different resource within a single subnet, or cross multiple subnet, or they can even cross multiple regions if needed. I'm sorry. So the multiple availability design if needed, and then you can scale them automatically as well. So behind the scene, you can have those auto scaling group. You can define the auto scaling group to your compute resources. So there are two different types, actually three different types of the load balancer. For the application load balancer, which work on the layer 7, and for the network load balancer, you work on the layer 4 of your network model. So actually, in the network load balancer, you can define IP as the destination. So in this case, it's actually you can scale it to anywhere you want. It's not limited to the AWS network. So there is another classic load balancer. It actually has both layer 4 and layer 7, but we are gradually, retiring that product. So you want to make sure, the first choice for you are the application load balancer and network load balancer that work on the layer 7 and layer 4. So there's a different options for you to route your traffic. And in this case, you can think of using the Route 53. So what is Route 53? It's basically is a DNS services, but it's a DNS service with some intelligence behind the scenes. So what you can do is you can register multiple, DNS resolution behind the scene, and based on different policies. For example, you can have latency-based routing, or that means it will the Route 53 is smart enough to detect how fast the target is responding, and then based on that, it can give the name resolution based on those information. Or you can have the geo-based routing, or you can even have the round robin and weighted round robin. So there are multiple choices. You can use Route 53 for your distribute to distribute traffic based on the policy that you define. And on the other hand, Route 53 not only resolve the external, public, and you can use that for private DNS as well. All right, so 30 minutes and we got through all the slides very quickly. And I know it's again, although it's already shortened slide, but it's a lot of information. Do we have any questions so far? And always welcome to pin us through the chat or through any way. But just we don't stop here. We want to help you on your cloud journey. And like I just take you through a journey of the VPC. So the next 30 minutes we are going to spend on the VPC lab. So the plan was to have you guys just go through the document and then follow that through the lab, and then see if you have any questions, and then you can just pin us. I mean, just talk us. But then now I realize this is like a webinar, and there isn't much interact between. So what I will do is I am going like similar to Lance and Brian. We will go through this document, and I will just do this lab on my screen as well, so you guys can follow, or you can do it later. So for the lab that we created on the lab we created on the account that you can use, we will keep until tomorrow. So after our session ended, you can still follow this document and to use the resource there, and don't worry about you can clean up after you create the resource, or if you don't clean up, they will be deleted tomorrow anyway. So just take your time and do whatever you want after our lab ended. Okay. So so for this particular any question before we start the lab? Okay. So for this particular lab, that what we are going to do is we will create we'll put everything that we learned earlier in the presentation into a a lab environment, and we are going to do it hands-on. So what we are going to do is, first of all, we will create a elastic IP, because we want to assign this IP to and then we will create we want to use the VPC wizard to create a public subnet that we just mentioned, a private subnet, and then behind the scene, it will create an internet gateway, and then it will create a net gateway as well. So this is the first practice. We are going to create the elastic IP. We use that for the net gateway during our VPC creation wizard. And then once this VPC created, we will practice a little bit about the security group. What we are going to do is we are going to spin up an EC2 instance, and we are not going to do anything with that EC2. We will just try to pin it and to see how can we reach to the particular instance through the public IP address, and then what can allow or deny the access to that instance through the pin. And then eventually, optional, we can create another instance in the private network, so that's not going to be accessible through any means. So welcome to follow me, or you can just work on your own pace. And the document is available from the chat, the hands-out section of the GoToWebinar control panel. All right. So the first part is we are going to create a elastic IP. So like you see earlier from the different lab, we have on the left-hand side, you have different options, and then you will be able to go deeper on the right-hand side. So I go to one of the you know, a region, private subnet and public subnet. Interesting. I think I already used that subnet. Let me pick a different region. Let me see in this Virginia region. So, you know, on this top, we can have, oh, I'm sorry, this is a VPC. All right, so let me pick a region. All right, I'm going to use this as a Northern Virginia as the region that we are going to create this VPC. So the first thing we are going to do is create an elastic IP. So elastic IP is, as I mentioned earlier, this is a static IP address that you can reserve for your use and that will not change. And quick information about elastic IP, if you have instance up and running and the elastic IP is attached to the instance, a running instance, you are not charged for the IP address. But you know, if your instance is shut down and or your elastic IP is just located without attached to any instance, there will be minimal charge for that elastic IP. So the first thing we are going to do here is we are going to create a IP, locate a IP address. So nothing you really need to worry here. You create that from the pool, or you can bring your own IP if you really own the IP address. And tagging here, like most of the resource, you can do the tag. In here, we are not going to tag this, so we are just going to allocate. So here you can see that we got this IP address. So what we are going to do with this IP address is we will attach this to the network, the NAT gateway when we create our VPCs. Okay, so you can scroll up till that, you know, launch VPC wizard. So what we are going to do here is go to the VPC dashboard. You have multiple ways that, say for example, if you want to just create a VPC the way you want, you can just go to VPC and create it and then go through a bunch of the things. But to get you up and running, and by default, actually AWS create a default VPC for every single region. So you can, but normally you want to create your VPC so you have more control over the IP address range that you want to use. So here we are going to go through the launch VPC wizard. And we are going to, like its instruction, we will pick public and private subnets. So what does this do is, like the picture show here, we will create a public subnet, and then we have a private subnet. And behind the scene, there will be a net gateway. And of course, because we need access to the internet, there will be a internet gateway in this as well. All right, so here is, you can specify the IP range that you want for your VPC, and then as well as your subnet. So this is, you should plan in advance to plan for what do you want for your network scheme. Okay, so now we have this /16, so basically cover everything 10.0.0.0 to 10.0, 255, 255, and so you can use anything in between those for your network. So here, the first, you create a couple subnet. First one is public subnet, and you can pick the availability zone you want, but you don't have to. So you would, in this case, we'll just leave it default. It will pick by itself. Then also you have this different subnet in the different /24 IP address range. And in this case, it's going to be and you can name it. And this is, you don't have to name a public subnet. You can name it anything as long as you can, that makes sense to your usage. And you can have multiple public subnet, you can have multiple private subnet. So it's not limited to only one and one. Okay. So here you can pick your private subnet, and we want to create a net gateway. So that's where we create the elastic IP address earlier for. So we are going to, when you click on this, it automatically populated any elastic IP address which is not being associated. And you pick this as your net gateway IP. And once this is done, you can just create this VPC. So normally create VPC is pretty quick. It's just like 10 seconds or the subnet because they are logically defined boundaries. But in our case, because we are going to create a NAT gateway, so it will take a little bit longer. So this might take 3 to 5 minutes. So I hope you are following that. So maybe you are here as well. So let's wait for a couple minutes until this NAT gateway got created. So once it's done, you will see a VPC successfully created screen. So in the instruction, you say, wow, you only took a few minutes. But it is true, right? Think about how basically if you are running a physical data center, not only you have to sign the contract, you have to go to find an ISP, give you a handoff, and then if you will need to monitor devices and just to create all the network needed that you want. But in here, the scale of the cloud, we are able to allow you to do this in just few minutes. All right, so now it is done. We have this VPC created successfully. And so let's just click on OK. And we can see that the dynamic test. So this is a brand new VPC that we just created. All right. So basically in the instruction, it want to explore through few things that we mentioned earlier that in the presentation. So like the route table, things like that. So let me quickly just without following that, let's just explore through these things quickly. So this is a VPC that we created. And if you see the options below, there are some options, details about like IP range, or you have what is the CIDR CIDR range that you created for that particular VPC. And Mohit mentioned the flow logs, there might be something. And then if you have any tags, it will be here. And in the details, you can see that there is a main routing table. So what does a main routing table means is for everything within that VPC, if you don't specify a routing table, and this routing table will associate with that. So if you click on the routing table and go into the details about the routing table and what defines your routing table, most importantly is of course the routes, right? So here you can see there are a couple of routes here. And the first one is the local route. What does that mean? So you can see this range is basically the entire CIDR that we define through our VPC. And so go back to what I mentioned earlier, by default, when you create your VPC or the subnet within that VPC are automatically routable because of this default route here that you have within your range of your CIDR, that's the local. Now, on the other hand, we see the second route, and we only have 2 routes here. Of course, you can add your own routes. And the second route here is 0000/0. That means it's default route. Everything is go through this if there is no match on the other routes. And in this case, the target here, you can see that it's a NAT gateway. So why do we want this as the default route? Because by default, it's not the best practice if you go to the internet if you allow your subnet go to have a internet attached. So in this case, this is a launch wizard, and it automatically create a the best practice. So the default route, the main route table is the one point to the net. So in this case, that means by default, when you create a subnet, it will have the internet access through the net, but it will not be able to allocate a public internet. All right. So if you click on this X and get out from this particular route table, and you can see we have some other route table here, and we can go back to our VPC as well and go to the subnet. So you can see that we have a couple subnet that we just created. So there is a test, that's the test VPC we created. So this private subnet and public subnet are created automatically under our VPC. So let's take a look on the public subnet, okay? So if you take a look on this public subnet and take a look on the route table, you can see the default route, the 0000/0 is actually pointing to the internet gateway. Okay, so in this case, that's what makes this subnet a public subnet. So on the other hand, if you go to the private subnet and you take a look on the route table, and that's associated with that gateway to the net gateway. So this is the private net subnet because it does not have a route to the public internet. So I hear sounds. Do we have anything that we need to? Okay. So the next thing, what I think we can do one more practice here is based on this hands-on lab is we are going to create a EC2 instance, and we want to see how can we access that EC2 instance. All right. So what we can do is we are going to create like Lens showed earlier. It's easy, very easy to search right now with the new interface, and you can search the EC2. And let's go to the EC2. And you can go to the instances, and let's launch a new instance. You can just pick the default AMI, the Amazon Linux AMI x86. By the way, you have option here, ARM. I think Lens also mentioned the ARM processor, and which is a very efficient way if your application is ARM compatible, and you will be able to save, up to 40% if you and give you a performance gain as well. So we can just keep it T2 micro and configure. So this is where you want to pick the network. Just make sure that you pick the test VPC that we created earlier. And then the subnet, you have the choice. Once you pick the VPC, you have the choice of your subnet that where you want to create this instance. So let's just pick and this one we want to get IP address. So let's pick the public subnet. All right. So we are not going to auto assign a public IP just yet, because we want to try to create another elastic IP and then attach to this later. Okay. And for other like placement group, this is some options for you to gain either distribute your traffic or gain better performance within the instances. So there are some options there you can choose. You can attach a role to you that's related to security, so your instance can connect to the services without extra authentication. All right, so there are some options. I think you can explore them yourself. So this is storage. We just keep it as default. We are not going to add any tag. And security group, if you do not specify anything, it will create a new security group for you. So as you know earlier, what is a security group about? It's a virtual firewall, stateful firewall attached to your instance. And then there are rules, and all the rules are allowed rules, because if it's not allowed, it's denied. And in this case, we have a single rule here by default because this is a Linux instances. It has a default rule because you want people to be able to SSH in. So in this particular rule, you can open up the port 22, which is used by the SSH, and you can specify the range. So basically, let's just say anywhere for now. But you can have option to limit it the source as needed. So normally, if this is a bastion host that you want to go into, you will want to pick only the IP address where you know it's a good source. Okay? So now let's launch. So it even give you a reminder here. It's open to the world. And so, yeah, we know that. And we are going to delete this pretty quickly. So we're going to launch it. You know, normally you might want a key pair to log into the instance, and you can choose your existing, you can create one. But in this particular case, because we are not going to log into this instance, we can just proceed without a key pair. And because all we are going to test is just a pin, we are not going to really physically log in like Lance did earlier. He got a key pair and he logged into his instance. All right, so we are going to launch these things. All right, so you can click this one. So we wait a little bit until this instance should be up in a couple minutes.
And Cheng Lang, I think a few people wanted to actually know the exact time that their lab credentials will expire in case they wanted to, continue to explore within the portal there after immersion day today. If you can give them the exact time for tomorrow, that'd be great.
Actually, I checked that earlier. I think I just enabled that this morning at 8 o'clock. So you have until tomorrow morning, 8 o'clock Pacific time to terminate that. They will be terminated after that.
Awesome. So for those of you that have been messaging me either with troubles in getting in or just anything to do with the lab, how to access, just any questions you may have, definitely by the end of today would be the best time to get your questions answered. Thank you.
Thank you, Melissa. And thank you for those came out with the questions. And sorry to hear that you have trouble getting, but just let us know if you need any help to get it. Okay. All right. So now we can see this instance is running. So there is no So when I pick this instance, you can see that there is a private IP address, and there isn't a public IP address attached to this yet. So since we want, this is in the public network, and we will be able to assign a public IP address so we can try to access that. So here is, we are going to attach a public IP address to this. So what we are going to do is we are going to remember earlier during our launch wizard, we can actually pick locate a IP address range. Then in that case, it will just randomly assign an IP address. But in our case, we actually want to try to allocate a elastic IP address. So we have control about what IP address we are going to assign to it. So here, let's allocate another IP address. So similar to what we do earlier. So let's locate this IP address. So this is the new IP address. By default, you actually filter to the new one after you create it. So what we can do here when we have this IP address selected and go to action, and you can choose either release or associate. In our case, we want to associate to the instance because I copy. Remember here, I just copy the instance IP ID of this particular EC2 instance. And what we want to do is I'm just going to paste that instance ID to this. All right. So now it is associated. Let me refresh this screen. Okay, so now you can see that we have this public IPv4 address associated with this device, this instance. Okay, so let me copy this, and then you will think that if you have any like terminal, like Windows or Mac, you have terminal program, you can try to pin this IP address. You would think that's usually pinnable because it's a public IP address, right? But it is not. So you can just think about what could be the case. And remember, we mentioned earlier, there are two ways that we protect our instance. And during our creation, we actually create a security group. And for that particular security group, we have port 22. All right. So in this case, that's the only rule that we have. So under the instance security, you can see the security group. So if we open this security group, we see that there is a SSH open for the TCP port 22. So let's see, can we just add another rule that will be allow, ICMP. So ICMP is the protocol used by the pin, and we can just leave it custom, and we can have it anywhere similar to what we have for the SSH. Okay, so this is not the best practice, but this is for this test we are going to do. And you can easily try it from your own computer. You can pick my IP, and you actually will find your IP address, the public IP address that associates with your location right now. So you can limit it to only your, especially for the SSH query, that's something that you want to do, just limit it to only certain locations. Okay, so in this case, let me apply this rule and save this rule. So now we have this rule associated with this changed, and at the same, it create another rule that allow the ICMP. So let's see if I can do the same thing here. You can see that actually ICMP got replied. The reason for this is we have that instance label of the firewall attached, and you can see that we only specify anything which can come in. And in order for my terminal to receive the reply, actually, because it's a stable firewall, it actually automatically allows the traffic to come back to me. All right. So at this point of time, I think we are probably about the time, 12:27. I think this will conclude our lab and or our material today. And really, thank you so much for, it's a very packed 4 hours for all of you. And then I think there's a lot of material. And feel free and welcome to reach out to the mission or AWS to if you have further questions.
Thanks for attending today, everybody. So we're going to wrap up the workshop. Hope everyone has enjoyed it. So we were planning to do a poll. Melissa, I'm not sure if you're at your workstation. Yeah, load up that poll for me, please. And so the poll is essentially, would you be interested in speaking with Mission about this workshop? Basically like a follow-on conversation, any sort of consulting work you might be looking for, or even just insights if you're evaluating some sort of move. So let us know in this little poll. So for those that were here and participated, so we are offering basically an hour of consulting that will be paid for by AWS. So we can discuss any sort of migration readiness or cost analysis, and answer any questions you might have about a potential move to AWS. So we're happy to get on the line and chat through any of these things. And so for that hour consulting, we'd be bringing on one of our certified engineers. It's probably going to be me, to be honest, or another solutions architect from the Mission sales team. But we get on the line with you and walk through any sort of technical or even non-technical detail about any sort of AWS related workload. So feel free to reach us at any of the channels that you see there. So at our website, missioncloud.com, you can email us at sales@missioncloud.com, and our telephone number is listed there, also available on the website. So we will be sending out a follow-up email tomorrow, and so that will it'll be linked to the free AWS training and certification ramp-up guide, and a copy of the presentations that we've shared today. So all this content we'll be sending to you all. You will still have access to your labs for several more hours, I think, till tomorrow morning. I think it's a 24-hour thing. So take use of those labs. You can go through at your own leisure just before the time runs out. Aside from that, if there were no other questions, I think we can wrap this thing up. Thank you all so much for coming.